Associated with the Solar Decathlon for 3 years now. I joined as a student design participant, so I understand how nerve-wracking it is to present here. And this year I'll be helping out as a jury coordinator. I'm joined by Chrissy, who's a jury assistant here at Enroll, and she works here at Enroll as well.
Hi, everyone. Nice to meet you.
So we're very excited to host a hybrid event, and we welcome you all and thank you all for joining us both virtually and in person. Each year we've seen a lot of creativity, ingenuity, and innovation come out of this competition, and we're very excited to kickstart the events of the day. Based on the presentations from the semi-final competition, we have 10 teams moving forward, out of which we'll select 3 finalists, which will be announced in the grand jury tomorrow. I'll go over the agenda for the day. So we will be having 8-minute presentations followed by a 15-minute Q&A session. Please look out for Chrissy for a 2-minute and time's up warning. And post the competition, we will have a networking opportunity followed by the grand jury tomorrow. Just a couple of notes. We request you all to please remain silent while the participants are presenting, so as to not disturb them. And for all the virtual attendees, we request you all to stay on mute and keep your videos off in case when you're not presenting. We're also joined by 4 esteemed jurors today who are all industry professionals. We have Melanie DeCola joining us. Originally trained as a graphic designer, Melanie has been working in the field of architecture for more than a decade. From a start, designing layouts for Dwell magazine and Architecture for Humanity, she has always maintained an interest in high-performance design and complete her master's degree thesis on biomimicry. She even used images from the 2007 Solar Decathlon in a master's degree book about alternate architecture. Currently, she helps firms discover, apply, and share research occurring across the field as well as within academia as part of the research team at AIA. Previously, she supported research and marketing at Hycock, Cole Architects, and Gensler. She lives in the Washington, D.C. area, is a lead green associate and an active member of the Net Zero Energy Coalition for the District of Columbia, Maryland, and Virginia region. Okay. We're also joined by Greg Fisher. Greg is the founder of Greg Fisher Architects, an award-winning firm established in 1993. His practice focuses on simple, progressive, authentic, and responsible design. Greg's commitment to sustainability has led him to be an architect for many sustainable-oriented buildings and developments. He has also served numerous green causes and on numerous green and sustainability organizational boards. He was named the Colorado Green Building Guild's Green Champion of the Year in 2020 and the US Green Building Council's Volunteer of the Year in 2009. Currently, Greg took a sabbatical to design and personally build one of the first Passive House Institute certified homes in Northern Colorado. We're also joined by Jean Myers. Jean is the owner and CEO of Thrive Home Builders, a top 20 builder in Denver, Colorado, and has won 10 consecutive DOE grant awards for housing innovation for its high-performance homes. Every Thrive home is built net zero energy ready and LEED certified. Thrive is Denver's largest builder of US Environmental Protection Agency EPA indoor air plus qualified homes. Jean's career in urban development spans more than 30 years, from a civil engineer in the US Peace Corps in the early 1970s to starting his own home building company in the early 1990s. Jean is known as an advocate for smart growth and affordable housing. He frequently speaks locally and nationally on these topics. We also have Parag Rastogi with us. Parag is a building scientist with a background in civil engineering and 10 years of experience in research and development of health, well-being controls and controls products. His work touches upon health and well-being in buildings, Internet of Things-based control, integrating climate risk analysis into building performance evaluation and planning, and the use of machine learning and data science in software and hardware for buildings. So I thank all the jurors for joining us today. Do you have a quick few words before we begin for the teams, just as a best of luck to them? You can use the mics right in front.
Thanks for all your hard work, and I'm looking forward to a day of presentations.
Yeah, I'll chime in and just say this is going to be a lot of fun. So, so enjoy and
Don't forget the fun.
and be sure and watch all the other submittals that you can, because I learned a lot reviewing them.
Hello, this is my first time serving as a juror member, so I'm looking forward to learning today as well.
Yeah, same here. It's my first time as well. And I really enjoyed reading the submissions. So I'm looking forward to the presentations. Yeah.
Thank you. So we have a couple of minutes. We'll be starting with University of Texas, Austin at 9:15 a.m.
Can I move your charger to? Can I move your charger to this? Because mine won't fit.
Actually, this is not electronic.
No, sorry, this one. Right? Yours, right? So I'm gonna move it from down there to up here.
Sure.
I'll put plug.
Not a worry.
Okay, cool.
You got the international adapter, right?
Yeah, the UK plug. So
Yeah.
the UK plug is massive. So.
Yeah.
Thanks for being here. He's got the long one on. It's real obnoxious. I'm so sorry. Thanks for being here. We had a few, we realized some typos and slight inconsistencies in the errata summary. So for a few errata to highlight.
Thank you.
Thank you.
Move this much?
Yeah. 2 or 3 of us.
What's wrong with that?
So that Melanie and Jean can use
Okay.
and
Oh.
possibly even Greg.
Right.
But this might be just the close.
Okay, that's fine. I'll move it here. I guess, Greg, you're taking that mic and I'm moving this one to here.
Okay.
Yeah.
Once Jean will be here. Yeah.
Turn this off. You can't. Okay.
Just making that joke over
No traits.
Right.
Or is that for extra? It's just that.
You're welcome.
Yeah, when you just
Yes, we're gonna do that. This is gonna be so complicated because I put up the presentation.
Huh?
I think I can multitask. I can do it.
Yeah.
So, okay. Yeah. I don't. This is better. Right? That's fine. No, that's okay.
This is your job. Is there anything I can take from it?
I think we're fine. I'm just gonna like pull it up at 9:15 and then go from there.
Oh, yeah.
Yes. Yes. Yes.
Okay.
Yes. I love that. Okay.
It's
What do you think going?
beautiful.
Yeah.
Anybody read it? Okay. Okay. Well, so it's, yeah, it's our reference library, so when you close, it's short little. Thing is, don't you wait for- Just be aware.
My kite is always in trouble, isn't it?
So, where, virtual, if you just further devices, you would we also have an open call for paper, but it also.
That is. Oh, great, thank you. Is this good? Y'all can.
It's like you just.
And stop.
Yeah. So no intro, we just dive into it. Like from the.
Okay, got it. Yeah.
All right, everyone, 1 minute, please take your seat. Thank you.
All right, Yutyastin, you can start presenting.
Good morning, everyone. We are representing the University of Texas at Austin and the attached housing division with our project Soleil Homes. Hello, I'm Noah.
My name is Chase. And I'm Nicole.
Our UT Austin team is made up of an interdisciplinary group of students from architecture, engineering, planning, and urban design. and we are led by our faculty advisor, Michael Garrison. Austin sits within climate zone 2A with 1,600 degree days of heating and 3,000 degree days of cooling, meaning that we are primarily a cooling climate. Austin is also one of the fastest growing cities in the US, and with that comes an increased cost of housing, gentrification, and displacement of communities of color and low income neighborhoods. The site is also close to a transit corridor that the city of Austin is currently developing to encourage walkability and public transportation. Our Soleil Homes project is located in the Blackland neighborhood of East Austin on a 130 by 150 foot corner lot and consists of 14 units distributed around 3 buildings, 2 of which are row houses and 1 of which is ADA accessible flats. The goals of our projects are to address affordability, environmental stewardship, and neighborhood compatibility. The Blackland neighborhood is a unique neighborhood with early Swedish, but later predominantly Black heritage due to historic segregation in Austin. Our project seeks to mimic some qualities of the craftsman style prominence in the neighborhood, while also attempting to combat displacement through lower housing costs.
Okay, so as far as our design goes, middle density is one of our main tactics for achieving greater affordability while also having a design that's compatible with the neighborhood. And so with this Blackland neighborhood being predominantly single family homes, this increased density kind of reduces raw land costs per unit, so we can allow more people to live in this area of Austin. And so here we have the 6 row houses on the south side along 22nd Street. Then there are 4 row houses along the west on Paquito Street, and then 4 ADA accessible flats on the alley side on the back. The flats also have a rooftop canopy that incorporates garden beds and also an outdoor kitchen and a social space for anyone in the Soleil community to use. It's also shaded by a photovoltaic rooftop canopy that also collects rainwater. Okay, and this shows the interior courtyard between the units, and that's providing a communal space, and it's also a carefully considered rain garden microclimate with native plants and non-invasives that are also characteristic of the neighborhood. On the exterior, we opted for xeriscape lawn instead, using plants such as buffalo grass, which is native to that region of Texas, and it's a lot more resilient, uses much less water, much less maintenance, and our landscape is irrigated with drip irrigation to use a lot less water, and that comes from our rainwater collection as well as gray water recirculation. And this is just a little more detail on the water features in the courtyard. You can see it flowing down from north down to the west. This provides some evaporative cooling and reduces the thermal load during warmer times of the year. Plants are chosen as well on their transpiration rates to further reduce ambient temperatures. This illustrates a chimney effect that we have going on in the courtyard as well. The sun radiates the tops of the buildings a lot more than the bottom, and we're sort of creating an upward draft to create airflow. Most importantly, however, the inner courtyard is just really well shaded throughout the year, even during the height of summer, due to the proximity of those buildings. And for resiliency, we've mentioned the rainwater collection that's stored in these pillow bladder systems underneath the row house units. And so it's about 20,000 gallons of capacity, and that includes the gray water recirculation bladders as well. And that goes towards the landscaping. We also, in terms of energy resiliency, have a Tesla Powerwall for blackouts and emergency situations. And as far as construction goes, we partnered with Oak Creek Homes and Riverside Homes to prefabricate our units. Obviously, prefabrication allows us to reduce construction costs and waste in terms of material while optimizing craftsmanship and on-site construction efficiency. And the estimated modular cost per unit is listed here, about $115,000, and that represents 37% of our hard costs. Here we're illustrating just an attempt to reduce our embodied carbon, which comes mostly from our foundation. So we've opted for a perimeter beam foundation, and this reduces our concrete usage by about 228 cubic feet. And then next, we are just illustrating that we've provided some shared Zipcar units that are EV for carless residents at the neighborhood, because although this neighborhood is very walkable, transit oriented, especially in the future, you still need a car for a lot of things in Austin from time to time.
In order to optimize recyclability and carbon sequestration, we are committed to using local reclaimed and engineered wood products from sustainable farms. And in order to reduce operational energy and make sure the solar complex is as close to net zero as possible, we have included a package of energy efficient equipment, including Energy Star appliances, LED lighting, and advanced ceiling weatherproofing that will allow us to have an air change rate of 0.22 air changes per hour. And in order to encourage passive heating and cooling, we have strategically placed low E3 argon-filled double pane windows with exterior operable window shades at a window to wall area of 30%. In the winter, we are utilizing a radiant heating system, which is more efficient than a forced air heating system. But in the summer, a radiant cooling system would likely lead to condensation. So instead, we opted for a SEER 16 air source heat pump to power a 1.5 ton air handling unit with an integrated energy recovery ventilator. In order to bring the solar complex as close to net zero as possible, we have placed 160 450 watt solar panels on the roof deck of the flats and on the south facing side of the Pequeno units. Compared to the average Austin, these panels will generate about 25 kilowatt hours per day per unit under Austin's average 5-hour day installation optimally. And this will offset the anticipated 15 kilowatt hour energy use per unit per day. Compared to the average Austin house, each unit uses about half of the benchmark energy, and interior water use is approximately 1/3 of the benchmark with the additional help of our gray water recycling system. More than 1/2 of the entire site's watering for the evaporative pond, xeriscape, and buffalo grass lawn is provided by our rainwater system. Including solar games, our project currently sits at a HERS score of 2, and heating, cooling, and hot water encompass about 30% of our operational energy. The overall sales cost per unit is well below the typical market rate in Austin. With our green building upgrade, we are looking at $344,000 per unit compared to $600,000 for a typical single family home in Austin. And we are looking to utilize local affordability initiatives to provide 4 out of 14 of our units as affordable at $190,000.
Once again, our 3 main goals are affordability through mid-density prefabrication, zero net energy and subsidy programs. These affordability measures. Is it okay to finish the slide?
You can just wrap up in a sentence.
Okay, sounds good. So our 3 main goals are affordability and environmental stewardship, as well as compatibility with the Blackland neighborhood. This concludes our presentation, and thank you for your time.
Thanks, UT Austin. That was a wonderful presentation and a great presentation to kickstart the day. We'll now start with the Q&A. Melanie, would you like to go first?
Hello, thanks for being here. I had kind of a detailed question. I saw that you had the exterior shutters on the windows. Was that, did you consider interior versus exterior? Because in the US, it's not so common. What prompted that decision?
Yeah, we're really wary of the sun in Texas. And so like exterior, I guess the strategy there was to stop the insulation from coming in the building whatsoever, because once it comes through that window, it's just very hard to mitigate that heating gain. And so, yeah, stay on the outside.
Yeah. Interior window shutters, there becomes kind of a heating space in between the glass and the interior, and that contributes to a lot of heat gain. So we're trying to, again, prevent it from actually getting into the window and doing that.
You could have also mentioned kind of like storms and the resilience aspect too. Just a note. Yeah.
Yeah. Thanks for that. We did actually talk about that as well. Yeah. Thank you.
I thought this is a beautiful project.
Thank you.
I think the architecture is great, and I think the presentation quality was really high. You did a great job with EPA and Dora Plus, I thought. So good job. I may have missed some things in your cost analysis. I didn't see costs for, and I may have missed them. So I'm asking you this question not to like do this. I'm asking the question for you to help me with this. I didn't see the courtyard costs. I didn't see the big structure over the flats. And the rooftop deck costs, which all those are really expensive things. And so with your affordability goal, I was concerned about that.
I can speak to that a little bit here. As far as the photovoltaic array over the rooftop of the flats goes, there's an interesting program in Austin that's incentivizing both affordable housing and renewable energy. And so was formerly known as Solar Host. Basically, if you provide a certain percentage of affordable housing, we've got about 25% in our complex. There's an incentive so that it is actually paid for by Austin Energy.
It would cover the structure though. You have kind of a superstructure over the flats.
Right. A little bit fuzzy on that one.
Yeah, if you can pull up the cost of it, I'll speak to that more. Yeah, keep going. Yeah, you missed it, probably this one.
Well, and while you're looking, I don't want to take too much more time, but I really question, because you have affordability goals, why you would do radiant floor heat in this climate zone and then do a forced air system for cooling. I think you could have used your source heat pump and gotten both heating and cooling out of it and saved a lot of money and brain damage.
And I know we wanted to increase the efficiency of the system, and we originally kind of wanted to do radiant heating for all of it, but it's the condensation problem. But because radiant is from the floor and it's much closer to the occupants, that's why we tried the efficiency. That was it.
And despite Austin's history of being a very warm climate with climate change and things like that, we are experiencing really extreme cold fronts, such as the winter storm we had last year. So it is important for us to have heating systems as well, just for future resiliency.
Thank you.
And then on that point as well, part of affordability is the cost of bills as well, like the cost of living. And so by trying to reduce the costs to the person who's living in the building, that's also part of our affordability goals. Thank you.
Pass me that for sure. Nice job, guys. I too think it's a very handsome project architecturally, and a very handsome presentation of the project as well. Looked like maybe even had some hand drawings in there, or at least software that looks like hand drawings that were very beautiful too. Yeah, very nice. So you also selected some modules that seem to be sort of self-contained and very efficient in their individual units. I'm wondering if you did any exploration in modeling form of how the units related to each other, the orientation of the units, the juxtaposition. It seems that you have both height-wise and staggering horizontally. If there was some modeling that drove that you could speak to, or how that came about.
We unfortunately didn't figure out how to do an entire complex model in that way. We have focused on modeling for one unit, but as far as just considerations, we tried to use our basis of knowledge to try to make the best estimated decisions.
Yeah, we as I think we wrote, selected a unit kind of in between, so with two shared walls in the east and west. And so, yeah, that was kind of our baseline. We were able to kind of incorporate the effect of the shading from the overhang and the balcony on the south side. But yes, stuck to our capabilities on that section a bit.
Okay, thank you.
Thank you.
Right, yeah, I really like the project as well. And I love your solutions. My question is around maintenance and long-term sort of viability of the project. My limited experience of looking at houses in certain markets, all these technologies are great. Air source heat pumps, radiant flooring, they're fantastic technologies, solar panels, but It's who's going to maintain them when you guys have handed over the project, and now it's people who have no idea what these things are. So can you speak a little bit to the ability to maintain? I mean, I know Austin's a big city, and sure, there's probably some skills there. Can you speak?
Yeah, I think that part of that is like the skill base within Austin, and that's only growing year to year as hopefully these technologies become more common. But no, you're right. Like it is like some technology that's not every day, even though all of it's we've chosen kind of to be off the shelf and it could be implemented today. That is a consideration, but hopefully we can just bring expertise along with us.
I think something that's important too is to point out that the Blackland community actually has a community development corporation. We didn't specifically partner with them or anything, but they would be a wonderful resource in terms of like housing maintenance and stuff like that, because they're working on those kind of things in the Blackland neighborhood already.
To the community development.
Yeah, I was just gonna say, like, in this project, we did follow through with this project with the idea that we would cooperate with the Blackland community. That's a part of the reason why we chose to have 4 affordable units that are ADA accessible, is because, like we said, this is a low income community, a historic community of color, and a part about being compatible with the neighborhood is also a economic factor as well. Compatibility isn't just a style, it's also the ability to keep people there who can afford these places as well.
Yeah, sorry, I don't want to take time away from your questions, but we really are excited about like that partnership with the Community Development Corporation, because they would actually purchase the 4 affordable units. They already own 25% of the housing in the Blackland neighborhood. So they're a wonderful steward and an owner going forward as well.
All right, we still have a few more minutes if there's any more questions.
Awesome. I was going to say, to that point, goes right into this conversation. If you had included, even if you didn't partner with the community development, if you did, I don't know, knocked on a few doors or just kind of got a resident point of view and talked to like people in terms of this is what they want to see in their future housing, it just would have like pushed the presentation over the top. Because I think in the market analysis was a little bit light in your presentation, but that would have like been the cherry on top.
Yeah, I will say I definitely attended meetings because the Blackland organization does hold meetings. And I and our faculty advisor, Michael Garrison, because he lives in that neighborhood, he invited me to a bunch of those meetings. There was a project called Code Next in Austin that is pushing for density in like urban neighborhoods that have like 1 family house like style architecture. And one of the problems is that the neighborhood rejected the initial plan that was more dense than this. And so what we did is that we presented this as an option. And from the feedback we've gotten, this seems more likely to be approved by the neighborhood than what was initially brought forth. Yeah.
Good life lessons.
Yeah, that's great feedback too. As a community regional planner, I like all about that too. So it would be lovely to incorporate. But yeah, that like this project, the design, everything is like behind the scenes super driven by all of that. It's something that's kind of negotiated as what the neighborhood would accept, because Code Next was a scarring experience for the city of Austin, and yeah, like decades of trying to plan for like smart growth, kind of all down the drain. So this is like trying to get towards that again.
So can we shift gears a little bit and just go into a little bit of detail on how you did your life cycle analysis?
So unfortunately, we weren't able to do a full tally run through of like comprehensive all materials. So we had to stick to sort of bits and pieces, and the foundation was of greatest concern to us as sort of the lion's share of embodied energy in buildings. So we were able to mitigate that to a large extent, and we really wanted to focus on wood products as a sort of carbon sequestration technique as well. So we threw in a lot of wood finishes, reclaimed wood flooring. But yes, as far as the like a tally analysis, did not quite get there, but we feel confident that we've been able to mitigate a large amount of it through our actions.
Thank you.
Thank you.
I had a question about the resilience aspect of it, because Austin's kind of Texas becoming this climate which has much more cooling requirement now, and it will continue to have, but you'll also have these insane winter storms. Right? So how do you expect your systems to behave? Because you don't generally need them for a lot of heating, but when you need them, you really, really need them.
Yeah.
Especially like speaking to your radiant floor, like what is that? I'm sorry, I forgot. What is that driven by? Is that a gas boiler that drives that? Or is it air to water heat pump?
Yeah, air to water heat
Okay, so it's all electric.
Yes.
What happens when the electric grid goes down, which it did just last year, right?
Yeah, it did, yeah, for a whole week.
And will continue to go down multiple times in your lifetime.
Yeah.
Right?
The Tesla Powerwall was kind of an attempt to, at the very least, get people to a place where, maybe they can like focus it in one unit, or, at least have enough electricity to get it to where they can, because Austin does have like warming shelters for that type of thing. It doesn't happen often. It doesn't happen every year. This past winter storm was like the first time it's ever happened. So our infrastructure in that regard is continuously improving. But like as far as, it's
I mean, that winter storm was a big learning experience. The Tesla Powerwall, there's just one, it's about 12.2 kilowatt hours capacity. So we're thinking plug in a wall heater, isolate to one room. And that was a week-long experience in 2021. We also have community shelters that open up. But the very next day, I think after we had our blizzard, for example, in 2021, February, the sun was shining like brilliantly. So we could also expect the ability to recharge the battery storage over the course of the next several days. And so you're charging your phone, you're staying warm enough. And yeah.
I think also to that point, designing for extremes is sometimes really hard to do, especially like in the case of an electric power grid failure. I don't think anyone, but the way that we've designed this, like unless you lived off the grid by yourself and weren't connected to the main power grid, there's a way to really mitigate the effect of that on people if you don't have community resources in order to keep people warm. But having said that, I think it's also really important to point out that designing for extremes is very different than designing for day-to-day. And for day-to-day, we really did want to push a lot of the passive, either cooling or heating that is in the building. And I think we did that with our design to the best of our ability.
All right, looks like that's all the time we had, but thank you so much for presenting. We will have we can have a round of applause for the Q&A session.
Thank you.
You have Ryerson University presenting at 9:45 a.m.
Okay. Great. Got it. Thanks.
All right, you may start your presentation.
Good morning, Solar Decathlon jurors. This is Ben Brown, and my name is Stanley Francis Blick. On behalf of Ryerson University's attached housing team from Toronto, Ontario, we would like to thank you for allowing us to present our net zero energy retrofit solution, Solar Row. We are a team of 6 Master of Building Science students studying high performance building design with the support of our 2 faculty advisors. The background of our project begins in the 70s with Toronto's suburban sprawl extending in all directions from the downtown core, where the construction of the CN Tower announced the city onto the world stage. It's in these such suburbs where we have piloted our Solar Row retrofit solution, specifically at Timbury Place, a cul-de-sac of 1970s attached homes that exemplified a typical construction of over 100,000 similar units in the Toronto area. These attached homes consist of 6 identical units running north to south, facing east, and backing onto the forested Highland Creek to the west. Each of the 3-bedroom units are 2 stories above grade, with an attached garage and a full height basement. Now we observed 3 key drivers driving our design. Outdated housing stock with rocketing real estate prices, increasing energy costs due to inefficient design, and growing public awareness that immediate action is needed to address climate change.
So what does this mean for our design goals? It means designing for scalability, using simple construction methods, and readily available products. It means achieving net zero performance, where annual energy demand is met by on-site renewables. And it means prioritizing occupant well-being with cost-effective improvements to the quality of life, health, and happiness. To realize these goals, we started by designing a baseline energy model in OpenStudio and calibrating it to within 8% of actual energy consumption. This gives us confidence that our data is accurate and reliable. Our results indicate that over half of the pre-retrofit energy consumption is used for space conditioning, followed by lighting and equipment loads. 73% of this energy also relies on the burning of natural gas, accounting for 93% of the greenhouse gas emissions emitted per unit per year. Our first step in the redesign was to calculate our energy budget using helioscope simulations of the east and west roofs, whose solar potential was maximized to deliver energy throughout the day. Informed by this and the importance of a carbon budget, our second step was to develop a retrofit strategy which limits additional embodied carbon by maintaining the existing structure. The resulting approach is scalable, prefabricated, insulated wood truss panel system to speed up construction time, replace the existing siding, and encapsulate the existing structure. To validate the new envelope performance and reduce thermal bridging, iterations of key interfaces were analyzed using therm simulations with adjustments to the design made accordingly. With the addition of passive house level windows and doors, interior basement insulation, and continuous air barrier strategy, the result is an easily constructible, scalable, and high performance envelope solution. To tie it all together, the prefabricated nature of the panels allows for a variety of cladding options and design customizations, thus modernizing the dated facade. In our design, we've opted for an attractive and durable metal roof with a robust fiber cement siding and panel combination. Our third and final step to reach net zero performance is to revamp the active systems. To do this, we've replaced the existing gas furnace with an energy recovery ventilator coupled with a high efficiency air source heat pump, all tied into the existing ductwork, again minimizing occupant disruption and construction time. Domestic hot water is provided by a heat pump hot water heater, replacing the natural gas hot water tank, again tied back into the existing plumbing. Rainwater capture is also utilized on the west roofs and stored in a below grade cistern, where it is then filtered for non-potable use. In addition to rainwater capture, the use of WaterSense toilets and fixtures and Energy Star appliances reduce freshwater consumption by 54%.
The estimated construction cost of our solar row retrofit is $51 per square foot, or 67% less than a typical local retrofit project. The upfront cost is offset by the over $48,000 in energy savings realized after 30 years. 30 years of net zero operational carbon and superior indoor comfort. In the coming years, Toronto will move from climate zone 6 to climate zone 5, with extreme weather events expected to become more frequent. In response, the solar row envelope provides an adequate thermal buffer between outdoor and indoor temperatures, enhanced by rooftop solar and integrated electric vehicle charging. The building decouples itself from the energy grid and its related costs and carbon, while promoting energy independence. A whole building life cycle assessment conducted using one-click LCA indicates that the total post-retrofit cradle-to-grave embodied carbon increases from 29 to just 35 pounds of CO2 equivalents per square foot. This minimal increase proves that the solar row strategy achieves high performance with low environmental impact. Our house as a system focus recognizes that the fundamental relationship between early decision-making, the ability to impact the design, and the impacts on costs due to those changes over time is incredibly important. An integrated design approach between engineering and architectural elements at the pre-design stage help us achieve optimal performance. However, achieving a scalable net zero energy design is only truly meaningful if occupant well-being is simultaneously improved. With proper enclosure detailing and continuity, an integrated this. However, achieving a scalable net zero energy design is only truly meaningful if occupant well-being is simultaneously improved. With proper enclosure detailing and continuity of the air barrier, noise, pollutants, and other particulate remain outside the enclosure, while conditioned air is held within. Outdoor air, pre-treated by the ERV and its HEPA filters, not only reduces wasted energy from the exhaust air, but ensures a continuous supply of fresh filtered air. Occupant well-being is achieved by these passive and active strategies, but our retrofit solution delivers an experience that is also complemented by user education. With a smart home monitoring dashboard, users are provided with IEQ and energy data, giving them control over how their home operates to maximize comfort and efficiency.
This efficiency is shown here with major energy savings in every end use category, including the elimination of natural gas and the introduction of heat recovery. The result is a 66% reduction in total energy use compared to the baseline. We see this as a massive success for not only the homeowners, but for the global fight against carbon emissions. All that's left is to include on-site renewables. To summarize, we started with a calibrated baseline energy model to give us confidence that we were working with accurate numbers. We then calculated our energy budget with on-site renewables and met that budget with a 66% savings in energy use through the redesign of the building envelope and active systems. Combined, Solar Row goes beyond simple energy savings, meeting the net zero targets of tomorrow's built environment and becoming operationally carbon neutral. Solar Row is a scalable net zero energy design template, ensuring occupant well-being using proven techniques for meaningful change. We are the Solar Row team from Ryerson University in Toronto. Thank you, Solar Decathlon.
Thanks, Ryerson University. Let's start with the Q&A session. Jean, would you like to start us off?
Good job.
Thank you.
So I thought this was a very, very strong submittal, and granted, you've got some architectural limitations since it's a retrofit, but I thought within those constraints that you did a fabulous job. The things that stuck out to me, I've tried to do therm. I saw therm all over your analysis. Therm is hard, at least it was for me. And so the fact that you went to that extreme to really look at what your before and after effects were going to be at all of these critical junctures, like roof to wall and foundation to wall. And I thought that was very sophisticated. I thought it was cool that you didn't just sort of pick your overcladding system and realize that was it the east side, it really needed to be stick built out there. I thought that was very sophisticated to recognize that, oh wait, that solution on the other side isn't going to work here. And so I agree with you. I don't think it would have worked there. So good job on that. I thought you did a good job on both operational and embodied carbon. And so I applaud your work here. The fact that it's scalable, that this is a big problem that you're offering a practical solution for, I think is just really great. So good job.
Thank you.
Sorry, I'm forgetting. Sorry.
No worries. No worries. Yeah, great job, guys. I really like the project as well. And at least to my way of thinking about sustainable design and sustainable building, I really feel like you guys get it. And it really resonated with me. I have a couple of questions I'd like to get to that are totally unrelated, but one is a technical one and one is an architectural one. So like Jean said, I think there's some challenges you face with retrofitting an existing building. And I think the energy sprung system and so forth that you chose to deal with the main mass of the building, I think really is handsome and enhance that main mass. But architecturally speaking, the garages really troubled me. And I'm wondering if you did any exploration of other solutions to maybe mitigate those visually. I have my own thoughts about how you might do that, but just wondering about that. And then on the technical side, your wall assembly is real interesting, and I like the approach. Well, you have a couple of layers that I'm not sure what role they're performing. So I'm hoping you could speak to them. And so right after the existing sheathing, you have a layer of 1-inch rigid and then another layer of OSB before you start the Larson trusses. And I'm just not sure what that role is that rigid and that OSB is playing in the assembly. So
So I'll answer the garage one first.
yeah.
Yeah, you pointed out one of the biggest challenges we had this project, because the garage is not climate controlled in anything, and there's no door to entrance of the house from the garage. You actually have to exit the garage and go into the front door again. So we did not want to insulate the entire garage. We want to do as bare minimum as possible there. We tried to, I don't think in the presentation we did not show a detail of it, but we tried to super insulate it with spray foam on the inside.
So sorry to interrupt you. I'm thinking more about the architectural side of the garages. Yeah.
Side, yes. So the rest of the house was initially clad in metal siding, and the garage is in brick right now. And so what we didn't want to do was take off all the body carbon that was already on the building, and so we wanted to keep it there. It's not the greatest colored pink brick, but you know, performance wise, we wanted to keep it as opposed to ripping it all off and adding more body carbon. It was a challenge for sure. It's the only thing that sticks off the building. The layers in the wall itself. So we have the existing sheathing of the house, which gets exposed whether or not there is an air barrier existing on the wall. And so in one of our slides, I showed an isometric. Should I go back to it? Sorry.
If you like, yeah.
Real quick back to show you. We don't know inside the wall right now if there is a proper air barrier. So what we said was we will either repair or replace the air barrier that's there. So that's the surface right here. And then what we would do is put a 1-inch semi-rigid mineral wool on top of that. And what we wanted to do there was to make sure there's no air movement and circulation behind the energy sprung panel. And then the energy sprung panel itself is the two pieces of sheeting with cellulose in between.
Gotcha.
So it's just that it is a thermal break, which is important, but we also wanted to make sure there was no air circulation behind it.
Thanks.
Okay, we're going this way. All right. Yeah, great project, guys. I'm really impressed by your energy modeling. So, I'm interested to know how you manage the calibration, because that's really difficult task. We deal with it every day. And if you could speak also to, you mentioned the fact that Toronto's recently gone from climate zone 6 to 5. It will be, right? Yeah. So the newest version of the ASHRAE standard does include a lot of these, right? Where not only do we have a new climate zone 0, everything is moving northwards. So what would change in your approach as you know that it'll get into 5 more and more? And the summers will become more extreme and stuff. Maybe nothing will change. Maybe you already accounted for that, but can you speak to those two things, please?
So I'll hand off the Open Studio question to Mohammed in just a second. He's on the call. In terms of the climate zone 6 to 5, I'm not sure too much would actually change in our design. What we really wanted to drive home was that if we do precondition air, we want it to stay inside. And so if it's really, really hot humid summers, which we are getting in Toronto very frequently now, we want the energy we use and spent to precondition the air inside the building to stay. And we want everything outside to stay outside. So those two climate zones, I don't think we would change too much in the design. Maybe in 50 years we have to revisit it and see what's going on. Maybe pull off some more insulation, more shading potentially. Yeah. So Mohammed, if you're on the call there, do you want to speak to the Open Studio question?
Yeah. Sorry. Can you repeat the question?
Question was that I found your calibration to be quite impressive, and could you speak a little bit to how you went about it?
Yeah, actually, we get the actual bills for the electricity and natural gas for the houses. Then we have after running simulations in the Open Studio, we started calibrating the Open Studio simulations to month by month to actually have similar results which we have from the actual consumption from the bills of the natural gas and electricity until we get 8% verified energy model within 8% from the actual and open studio results.
All right. Okay, thank you.
Okay.
So I think, again, it was very impressive on the engineering front, maybe not as much on the architecture front. It would have been nice to see a little bit more, I don't know, something zhuzhing up to some of those kind of 1970s, was that? Yeah, kind of row house look was, you know, it's a challenge for everyone. I was going to go back to the energy sprung concept. I know you didn't really mention much about it in the presentation, but you did more in the other documentation. Has that been done in Canada? I know it's been done in Europe, and wondering if you can talk a little bit more about how practical that is in terms of not disrupting the occupants, like you said. I think that's really key, and it's a nice touch. How realistic is that?
In terms of Canadian energy sprung projects, there are more and more upcoming ones. There's a few that are in the feasibility stages right now.
Okay.
But in terms of ones that have actually been completed, there's one in Ottawa that's done for the Ottawa Community Housing Group. And so mostly it's concentrated on social housing right now.
Okay.
And they were able to achieve net positive energy using the solar panels and the same type of panel design. So it was done in Ottawa, and then there is another one going on in Edmonton. It's the Sundance Community Housing, and there is an extreme weather kind of climate. So it's being done in multiple different climate zones, and another one's supposed to happen in Nova Scotia as well. But so far, it's been proven to be successful in Canada, and it's climate.
Did you get a chance to speak to some of either the occupants or the architects that were working on this?
Not the occupants, unfortunately. But I have been working with some of the different people across Canada that are trying to make a solid change across the country in terms of making this a real scalable strategy to implement in existing housing.
Has it been done in the US? Does anybody know? No?
I know. I know New York is actually a part of the Energy Sprung movement.
Okay.
They're part of the team that helps design these every year. I don't know if they've actually done one specifically, but I know they're involved.
Okay, I'm gonna look that up. Cool.
So I was sort of vaguely involved with the projects that ended up becoming Energy Sprung, right? There's sort of Horizon Europe projects. And one of the things that we found, and I'm sorry if I missed that in your presentation, but actually we needed to insulate the floors because, because of many buildings that's out there, listed buildings or the thing is. So did you guys find that as well? Is that insulating the floor was actually a really effective strategy?
Which type of floor? Like a cantilever exposed floor with a soffit, or
just any floor really? I guess, I mean, down to the earth, the connection to the earth, thermal connection to the earth.
Right. Okay. So I'll just run through them quickly. An intermediate section, intermediate floor interface, wall to wall. The energy sprung just goes right on the outside. On a cantilever floor with a soffit underneath, energy sprung goes on the exterior wall, and then sort of a closer pulled-in wall, and then we over insulated the soffit, and then the cladding underneath that. Foundation wall interface. The energy sprung goes right to it's a few inches below the top of the foundation wall, and then below that it's rigid insulation. It's waterproof, and then from there we transition to the inside and insulate to the inside.
So do you actually add any insulation to the floor as well?
To the concrete.
Yeah.
We did,
Okay.
yeah.
All right.
So we insulated the foundation wall along the top of the floor.
Right. Cool.
You had rigid. Didn't you put some rigid and then do a new basement floor?
Looks like we still have a couple of minutes if there's any more questions.
That's cool. Enjoy a chance, yeah. Maybe the microphone again. Yeah, I could ask you guys questions all day long, I think. But I saw a comment somewhere in your narrative about the cooling load increasing post retrofit. Could you speak to that a little bit? Yeah.
Mohammed, catch me if I don't say anything. We did notice that when we were energy modeling it. What we think this is we didn't actually add any extra shading onto the house at all. Now there's not that many windows to start with, but over insulating that much, we are keeping it a lot more heat during the summertime. I don't think it was too dramatic, the cooling loads increasing, but it did increase. So it did actually surprise us as well when we ran through the model. But yeah, it's a good point to look forward to for future projects. We could have maybe added some shading on it, but I don't think it was too dramatic to really affect the performance or comfort inside. Well, thank you for your questions. We appreciate the opportunity to present.
Well done.
Thank you.
We have a short break now. All right, University of Missouri, you may start presenting now.
Hello, everyone. Thank you so much for taking the time to hear a presentation on the Housing Hive, an attached housing project located in Columbia, Missouri. Our design features 12 residential units per building, a community gardening plot, a geothermal well field, and a green wall that spans the central circulation space. Our team's intention was to design well-designed housing with sustainability for our future residents. I'm Emily. This is Xander, Kelvin, Hanvin, and Cam, who have assisted on the project. Our team worked with several local partners in order to ensure the reality of our project. The site is located in the heart of Columbia, Missouri. It is a college town and home to the state's flagship university. The area has access to bike trails and offers public transportation right on site. The site is located in a climate zone 4A mixed humid, with cool to cold winters and long, hot, humid summers, and often experiences drastic changes in temperature. The site is 4.72 acres, and with a site of this size, we are able to blend the community and surrounding universities and neighborhoods because we are able to utilize our space and have the MU's mixed use team share over half of the site. In order to create an affordable, functional, and energy efficient housing, we have integrated photovoltaic power to create energy efficient design. Using passive ventilation strategies, our design encourages cross ventilation and natural daylighting. The landscape design teaches residents how to implement sustainability into their own lives, and the use of a geothermal heat pump is beneficial in this climate due to Columbia's reliant ground temperature, making it the most efficient system to mitigate the weather extremes. The housing hive is 3 stories tall, but on the west side, the grade allows the site to be 4 stories tall because it's below grade, and this is applicable through the building code. On the exterior, we have used native plants in order to create a pollinator pathway and pervious pavement that will be used whenever applicable. A stormwater collection system will divert rainwater away from the perimeter of the building. And there are 2 feet overhang on the roofs in order to prevent the sunlight from getting direct access into the interiors during the summer months. All the materials were chosen to align with our goals of affordability, personalization, and aesthetics. The design utilizes a similar honeycomb shaped footprint per floor, offering 8 2-bedroom, 1-bathroom units and 4 1-bedroom, 1-bathroom units.
Our team's goal for the engineering aspect of this project was to prioritize passive heating and cooling strategies, as well as storing as many resources on site as possible, so that we could limit our reliance on the city of Columbia for utilities. We knew that in order to achieve peak performance for these passive strategies, we would need an exceptionally airtight and well-insulated building envelope. The SIPS panels we're using for this project provide us with our values of 40 for exterior walls and 60 for our roofing. Closed-loop ground source geothermal heat pumps are positioned vertically on site. Engineers we spoke with when designing this project recommended a 2-ton system for each of our 1- and 2-bedroom units. Plumbing and HVAC were designed with efficiency in mind. We're using tankless water heaters as well as chasers that stack vertically throughout the structure, regardless of floor plan layout. Our target market for this project is undergraduate and graduate students pursuing careers in healthcare. Our team utilized RS Means software to calculate a total building cost after construction to be $6.1 million. We believe that this just goes to show what kind of impact efficient construction methods and choice materials have on alleviating financial burdens one might experience in a traditional living facility. In mid-Missouri, we experience natural disasters such as seasonal flooding, fires, and tornadoes. SIPS walls withstand these better than traditional construction. We've also designed a storm shelter where there's a space where someone can seek refuge should one of these occur. We've tied our PV panels to a Tesla power wall to act as a backup battery in the event of prolonged shading or grid outages. In order to prevent water penetration at openings in our exterior envelope, we've specified a drainage plane, self-adhered waterproofing, and continuous applied vapor barrier. We're using low-impact materials whenever possible, such as precast concrete, metal wall panels, and locally sourced materials. Using the tally extension from Revit, we understand that the CO2 emissions are greatest in the manufacturing end-of-life stages during our building's life cycle. In an effort to offset this, we're using Sempergreen wall and roofs in order to reduce CO2 in the atmosphere, improve biodiversity, and act as a natural air purifier. These systems paired with TPO roofing with an SRI value of 98 will also help reduce urban heat island effect. In order to passively regulate the temperature in our circulation space, our building utilizes the stack effect. We've also implemented a southern-facing trome wall, which acts as a thermal mat, absorbing solar energy throughout the day and releasing that as thermal energy at night. Rainwater collected on site will be integrated back into the earth as well as reused for toilets and on-site irrigation. The housing hive creates a unique blend of privacy and community. Exterior balconies are laid out to maximize privacy, whereas the central circulation creates a more interactive and community-oriented space. We've specified smart technology like a Honeywell thermostat and Halo RL4 downlighting so that users can adapt their space the way they see fit. Plug load timers reduce the effects of phantom plug loads, and Energy Star appliances maximize energy efficiency. The entire structure is ADA compliant and can be utilized by anyone. Air quality should be a top priority in any project, especially in dwelling units. We classify good air quality by 3 key elements: pollutant avoidance, point source removal, and fresh air distribution. We're able to achieve this by using ERV units with minimal thermal loss.
The housing hive uses solar panels with 380 watts per panel with a panel area of 3,360 square feet with a system size of 64 kilowatts. Our proposed photovoltaic array will reduce the HERS score from 44 to -7. Our team used Autodesk Insight and Cove Tool to generate an EUI score of 11.91 without photovoltaics and 7.61 with PV. To encourage the residents' awareness, we use separate meterings in order so that they can monitor and adjust their energy consumption as needed. Thank you for hearing our presentation on the housing hive, an attached housing project determined to make large strides in offering affordable and sustainable living in the heart of the city.
University of Missouri, we can start with the Q&A.
Nice job, guys. I'm always interested when projects have a metaphor, and the metaphor often can speak on multiple levels. And so I'm curious to know about the hive metaphor that you used, as to why you chose that, if it was deliberate, and how it informed the project. And then it seems to inform the massing of the project. And I'm also curious to know, related to that, what kind of analysis you did on the sort of hive-like forms relative to performance, speaking on both the aesthetic level and the performance level.
Yeah, definitely. So to start, this was like, I started my thesis project and this kind of shape formed from that. So the housing hive, when I think of like all of us are students, so we've lived in student housing for the last 4 years or 3 years. And just like creating an atmosphere and a community within the students that you live next to, that's kind of the idea of the hive. And then also with the your second part of the question, having this form as like the physical form. I think that when I first started, I really wanted to emphasize this area of like the balcony spaces that kind of like jump throughout the space, as you can see in that front elevation. So that was my initial thought of that. And then I also took that farther and wanted to have like a lot of exterior space because they have so many exterior walls that they can see so many great things. And with our site, we have so many great offerings like the community garden and the other team that we're using the same site. So we're able to, create such a community there within our site.
We wanted to maximize the privacy on those balconies as well. So that layout allows us to do that. So you're on one of those balconies, you're not within eyesight of another balcony. Within that central circulation space is all that community. You can see each other through these openings on the floors. But another thing, maximizing daylight with all these nooks and crannies that you wouldn't necessarily get with a rectangle. All of that just natural daylighting, not only for mental benefits, but just solar. I can speak to the house and pipe metaphor. You can think of it as the site is our queen bee and the residents are the working bees. So we have this garden that residents can work together and grow fruits and vegetables that they can use. The interior space where the 4 units go out into and are in the building, they can interact in there as, if you think of it metaphorically, beehive would.
Thanks. Just a quick follow-up. Did you do some assessment to the, there's obviously benefits daylighting and so forth to the added surface area and volume and form, but did you also assess the impacts of that on the performance and energy consumption and so forth? So
Using Autodesk Insight, we were able to see it's like it analyzes the whole space and it kind of lights up in the rough amount of blue, showing blue what's coming out. So that's why we really tried to minimize our surface area of windows so that we don't have too much energy coming out, but also making sure that we have like a very airtight envelope that's also thick that will keep the air in or make it cool or warm depending on the weather.
Thanks.
I guess it's me. Yes, I do like I know visually it's very pleasing not to have rectangles, but it's murder when you're trying to put furniture in there, right? But anyway, didn't mark you down for that. I have some personal experience of that, but I think you did a very, very good job overall. I mean, it's a very impressive presentation. Can you speak a little bit more to you explicitly considered indoor air quality, which I really like. You're staying character with that. And, you went through the right ways, reduce pollution, blah, blah, blah. Can you speak a little bit more to what your strategies are? I mean, at the end of the day, people bring their own furnishings in and with VOCs and stuff, you can't control that. So how do you think about that? Yeah.
So we're using that ERD essentially to bring in new air with minimal thermal loss. So the way that ERD is going, it's using the heat from the air that it's losing to the exterior to heat the new air. So less reliant on electricity to do that. Speaking of that, I could say that you said that people bring in the old furniture that has their own VOC compounds, but we do have cross ventilation through our building. Above the residential doors, there's a window where you can open it and the draft can go from top to bottom across the unit through the exterior windows. Within that shared space where you get on the elevator or take the stairs, we have that green wall, which the greenery will reduce harmful toxins and also emit oxygen to the air. We have various, I believe it's called point source removal in the bathrooms and kitchen. So that's going to figure out that harmful air as well.
Thank you.
Great job, you guys. You guys are one of my top scorers. And I think that's because it was so holistic, your project. You really thought about the site, the gardens, the indoor experience, and the architecture as well, and a green wall and all these different things. I noticed that you really took resilience into consideration and was impressed that you thought about what energy usage you would need for like a week of kind of passive survivability. And I thought that was really great. I had a question about your kind of audience, which is primarily students, correct? And I noted that I think in your materials, you were saying that people could live here for more than just a semester. Do you want to talk about, are you trying to create a kind of longer term community through the Hive and what you thought about that?
So first part, I think with me personally, like I have moved every single year to college, so that it's a huge process of having my parents, you know, bring our big car out, put all my stuff in, move to the next place. Sometimes I don't have a place to stay for the 2 weeks that, you know, I'm interchanging. So that's definitely something that I wanted to focus on in this complex, just because it has been such a challenge to like move my stuff every single year. What was the other part of the question I asked?
Oh, I just wanted to hear more about you, kind of the student audience and.
Yes, the student audience. So, we mainly are saying that are pursuing like a profession in health sciences or something like that.
Right, yeah.
With the pandemic that just passed, obviously, we have realized that they, you know, control such a big part of our environment and like our living area and community. So we've kind of wanted to touch on that. The location is so perfect because there's Boone County Hospital just literally right next door. It's probably like a 2-minute walk, and then MU's campus also has a large hospital that's probably one of the #1 hospitals in the state that, you know, we get airlifted a bunch too. So that is also walkable, bikeable, drivable to get there. And then with the 3 college campuses that we have in Columbia, there's like a pretty big amount of students that are students, first of all, and then students that are also pursuing a degree in medical science or else profession.
And, oh, go ahead.
Going through school, obviously, we're low income, and we want to make that available for us. On the whole site, there's our building, but there's also the mixed use building that students could choose to live in. So there's a lot of options there within that site, and I think that's beneficial.
Yeah. One other question. I think you mentioned that Columbia has its own kind of net zero energy goals, or it seemed like a pretty ambitious city to be in. I don't know if that's the emphasis or the impact of having the colleges there. So were you trying to kind of fit into the goals for Columbia as a city as well?
Yeah, sure. I definitely know that like we have goals in Columbia to make them more sustainable. I think this would probably be one of the most, you know, ambitious projects that we've seen. We haven't seen anything like getting built right now currently, but we definitely wanted to like align the community members' ideas with this project.
Hi. Did you guys do a model?
We did.
Where is it?
It's very nice.
I want to see this massive passive house window you've got too. If you lugged it all the way to Denver, we got to at least look at this stuff.
Okay, so it also kind of interchanges. We're able to, this one is glued down, but this is the main housing hive that you're able to take apart all these.
So somebody 3D printed this?
Correct.
Somebody did. Somebody in the back?
Helped us in the development,
All right.
on the site and the topography and everything.
Well
This
done.
is our SIPS wall.
This is only used as a example for the SIP wall. So for example, that is not a triple pane window. There's no fluid applied. There's no metal wall panels on there. So that's just to demonstrate the SIP.
Yeah, it's just to show.
Got it.
The SIPS wall panel that we're using. But on our 3D model, you're able to see this interactive space. So each floor has a hole in the circulation space, so you're able to like look down or see people up or whatever, and the sunlight's going to be, you know, coming through there through our clear story windows. And then this is our trome wall, so to say, with the trome on the back, and then we have a green
The
wall
green
in
wall.
front to, you know, emphasize the air quality in that space. And then we just have a curtain wall on the other side, so that we're able to, you know, take as much light in as possible into the trome wall. So it can,
Okay, room, extra credit on presentation. So it's a lot of work. Well done.
We live by LEDs that one of our local partners, HOK, provided us with case studies where interior green walls can be lit with LEDs and sustain themselves.
Great. Well done.
Yeah, I was gonna note that because I know some people have done green walls, and if you don't light them correctly to the bottom, it's just gonna die.
Oh, really?
Yeah.
yeah.
Be a brown wall?
Yeah.
Sounds like Denver, actually, a brown wall. Well, so I already had given you really high marks on the presentation, so well done on that. And I think you have a really interesting design. I thought your O&M discussion was strong, and I think your sensitivity to your occupant experience was great. But I'm the lousy builder on this panel, and so I bring a cost consciousness to this, and I feel like you've got a beautiful building, but it's complicated. Your cost analysis was $200 a foot. going to be really hard for you to afford that when it gets right down to it, unless the state rolls in with free money or something to get it built. And I just had some suggestions on what could be done that I don't think would compromise anything, but would pull a lot of cost out. The fluid applied WRB is great, but it's expensive. I think your ground source heat pump, we're doing a demonstration house in Summit County, Breckenridge, and we're going to use an air source heat pump that's rated to 32 below because of cost. And I think you could have probably saved some money there. Love the idea of the green roof, but those things are really expensive. And so I guess my constructive criticism, I guess is what it is it's so easy for you to get so involved. We do this all the time at my company, where wouldn't it be cool to do this? And wouldn't it be cool to do that? Oh, wait, the people we were designing it for can't afford it.
Right. Yeah.
And so I think that's an element of real world, it's reality that we have to deal with. And so that's just my comment on that. I don't know if you have anything to say about that.
So I think the prefabricated panels take down in construction time a lot, which would save cost there, but also there's a, I don't know if you call it a company, maybe a community in Columbia called Habitat for Humanity. We would not be relying on them entirely, but they would, in our theoretical project, be helping with the construction a lot as volunteers. So construction costs, we'd be cutting back on in this theoretical project.
There's also an opportunity for Columbia Housing Authority to come in and own some of the apartments and offer those as low income for residents that are located.
The last thing that I want to touch on, as I said in the presentation, the current Columbia housing is very expensive, but it's also kind of poorly designed. I've noticed I've lived in 2 separate buildings, apartment buildings, in the last 2 years, and like there was just like such minor details. Like right now, like I can't like turn my clothes hangers all the way like perpendicular, and I'm like struggling to get to the back of my closet. It's just like small things that they were just like speeding up the construction time and didn't think about like how it's going to benefit their users. And I think that's something that we tried to do in our design.
Yeah, Columbia also has an energy efficient initiative for low income housing. So I think that incentivizes the housing authority in Columbia in general to participate and let designs like this be built rather than drop them dead in the bidding phase.
Well, I'll share a below the line comment about my own company. That great purchasing department is where great ideas go to die. And so it's not a mean criticism. It's just, we live this every day, and you will too. I hope you stay. You've done a great job. I hope you stay in the field. And I think you did a great job. Thank you.
Thank you, University of Missouri. That was an excellent presentation and a Q&A session. So.
Sure. Yep, thank you. Since it's past presentation, can we give a little plug? So our mayor, who was just newly elected, went through Solar Decathlon and led one of the first University of Missouri teams. And so now, and she was previously the sustainability manager for our city. So we're super hopeful that with her in charge, that we're going to be able to make things like this happen.
Great.
Shout out to Barb if you're on there.
This is background again. I always forget. He was a lawyer. Steve Adler. Steve Adler.
On with their videos on. Would you like to control the slides? We have another minute till you start.
Yeah, we would like to control the slides. Could you give that access to Levi Johnson?
Sure. Yeah, just try requesting access. Yeah, you should be able to control slides. Just try advancing.
The Zoom account, Levi Johnson, he's not able to connect to the Zoom. He is on Jorge's computer right now trying to get that control access.
Okay. Yeah, I see. Could you try advancing the slides for me? I think I just gave control to Jorge. Okay, that looks good. All right, so I'll let you know when you can start. And just a reminder, you have 8 minutes of presentation time followed by a 15-minute Q&A. So you can start presenting now.
Muted. You're muted.
You guys are muted. Please unmute yourself. Okay, we are having some technical difficulties still.
Because we're controlling it, we can't unmute ourselves.
Because he is controlling the slides, apparently he is not able to unmute himself.
You should be able to unmute and then go back to advancing slides. That should work.
Can you guys hear me now?
Yes.
Okay. Let me return to full screen.
Control L.
Now we have an
Well, hello and welcome to the Heritage Homestead. This housing complex was designed by the Kansas State Green Wildcats. Our team consists of engineers from the Department of Architectural Engineering, as well as architects from the Department of Architecture, Planning, and Design.
Our site is located just 2 miles west of Mission, South Dakota. This is located on the Rosebud Native American tribe land. And we chose this area because we wanted to target multi-generational living with our project. We wanted to be mindful of the people that we are designing for and recognize that they are very community focused. So we wanted to create a multi-generational home with a community focus. So we created 3 different living quarters with a community area in the middle. This allows for privacy and the 3 different living quarters, but then that community aspect is still there with that community area. If you look at the sections, you can see how the housing is terraced. This allows for more natural light to come into each of the units. And if you go to the next slide, you can see how there are a lot of south-facing windows, which allow for passive heating.
Taking a look at our HVAC systems, we are utilizing a ground source heat pump consisting of 18 boreholes totaling 18 tons of cooling. Each hole will be about 200 vertical feet deep to accommodate the cooling loads. Our main pumps and equipment will all be located in the basement, and then they will follow the duct paths shown in this isometric view in order to deliver the air to each space. To assist our system with insulation, each hempcrete wall has an average R value of about 26.
We cannot hear you. Would you be able to speak a little louder?
You can't hear us either.
our cooling.
We still can't hear you.
Jorge, we can't hear you.
Our total build and construction cost comes in at just above $400,000. And that includes buying the land, all 3 units in our community living space. This total comes out to about $140,000 per unit. Because this is multi-generational living and because we are on tribal land, our project qualifies for several state and federal grants, which brings our building costs down significantly. Our total will then be $300,000 at approximately $100,000 per unit.
We feel like our building was able to
Jorge, I'd like to interrupt you just for a minute. We cannot hear you. So if you want to move closer to the microphone.
Water resistance control
message in chat, maybe.
Control building on the thermal and moisture removal. On the interior, our lime wash, our lime wash allows breathability for we use all sustainable materials for our building. Starting with our hempcrete, it's made out of hemp and lime. Both are low carbon impact materials in production. We will be using cork flooring, which again, another low carbon impact sustainable material. Along with all our materials, they're all locally sourced, cutting down on carbon production, on shipping as well, and then supporting our local communities. Each unit is going to produce about 4 tons of carbon per year. And at the end of the use, because of all of these biodegradable, sustainable materials, our building would just return to nature after it's done using. Looking at our integrated performance, our self-sloping roofs will help our solar water heaters get their necessary solar load to heat our water, as well as those roofs will also allow water collection for our plumbing systems. Looking at our stepped design for the house itself, our windows will allow natural ventilation and cooling through opening them throughout the house, as well as solar heating from the south-facing windows.
We wanted these spaces to have a really homey and cozy feeling. This comes through in the cork flooring, which is very comfortable on the feet, as well as the lime wash on the interior and exterior for continuity. There's lots of access to the outdoors from each of the units, as well as a central shared outdoor patio for all of the residents. Lots of natural light in all the spaces with operable windows. All the appliances that we selected are very energy efficient and designed to last. And the same with the pendant and recessed lighting. And one of the units is also fully ADA accessible as well.
For acoustics, we separated each of the 3 units, so you're just not hearing your neighbor. And then we also use cork flooring to help with acoustics.
That way, here we have our lighting model of the floor plan view of our community dining space. And then here we have an isometric view of the same space. This just shows that we are adequately lighting our spaces, as well as keeping under the maximum wattage per square foot value given by the IECC. In each space, we will have a vacancy sensor controlling our light systems. This will just reduce lighting waste and energy waste from unoccupied spaces. We will have a solar array of about 8.5 kilowatts using bifacial solar panels on the west side of our building. That will just help produce the amount of energy we'll need for all of our systems in our building. Without solar, we'll have a HERS rating score of about 65, and with solar, we will have about a HERS rating score of 38. This is our heritage homestead. I hope you enjoyed our tour and thank you for coming.
Thank you, Kansas State. We can now start the Q&A. Parag, would you like to kick us off?
Right. Yeah. So this might have been part of the presentation, but I think we couldn't hear part of it. So I'll ask this anyway. I missed a little bit of the, I think you're addressing a very real problem, and I really appreciate that. And, it's clearly well-defined, your problem. I'm missing some sort of consideration of resiliency. Can you speak a little bit more to your ideas and plan and design for resiliency, and what you're planning against?
Yeah.
Wait, Jorge, sorry, we can't hear you. Hello, Jorge. Okay, can somebody go in front of the camera and tell him? Jorge, we can't hear you actually at all.
Sorry, can you say that again?
We can't hear Jorge at all. Your mic isn't omnidirectional, I think, so you have to face it. Try now.
Can they hear you earlier?
Can you hear me right now?
We could hear you earlier, Levi, but Jorge, nothing. It's a bit better now, yeah.
So,
okay, getting there.
So we were able to help with this by having a south sloping grade for our site to move water away. And we also have south sloping roofs to help with that as well.
Okay, thank you.
So adding on to that, I saw that you had some underground spaces, and I thought that was kind of a missed opportunity if you wanted to think about tornadoes or storms, or using some of that underground space as sheltering space. Would have been a nice extra touch. I was going to ask about the biodegradable materials. It's a great touch to have these and explain what they are, and they were beautiful materials. I was wondering if you had thought more about your end of life deconstruction. I know you said the materials would go back to the earth, but had you thought about how that would happen, whether any of the materials could be reused? Or I would hate to think of these places just being abandoned after they were left.
Yeah. So obviously a lot of the non-biodegradable components, like the glass, maybe some of the metals, could be ripped out and then reused for other projects, maybe melted down, especially any steel components. Other than that, the other materials could probably just be demolished and then buried if that was legal in this area.
Well, I think your concept of trying to deal with Native American housing is a good one. And I really like the simple forms that you chose, because I think that's actually what it takes to get to affordability. So I think your concept is strong. You discussed low carbon, and you kind of bought into the hempcrete really early. It sounded like I wasn't quite sure you had enough R value in this building for your climate zone. You talked a lot about how low carbon it is. I didn't see a life cycle analysis in the presentation. Did I miss that? Or can you elaborate a little bit on that?
We didn't have any diagrams or anything showing that, no.
Okay, and then in your presentation this morning, you talked about HERS analysis. Did you include the HERS analysis in the presentation?
I had some troubles with the program itself, and so I wasn't able to actually save the actual analysis that I got from that.
And so this morning you said it was a HERS 65 without solar, and was it a HERS 38 or 48 with solar?
38 with solar.
Okay, thank you.
Hi, guys. I also agree it's a much needed project type. Very much appreciate you attempting to solve that problem. I also think you're off to a really, my intuition says you're off to a really great start in terms of how you're expressing the project. But frankly, you left me wanting more. I wanted more support of all of the various components that you're including in your analysis as well. So, but it looks very exciting to me. I just want to see more. In terms of questions, one of the things I also was hoping maybe you could speak to was sort of the surrounding context architecturally. You talked about it a little bit culturally, and I have somewhat of an understanding of that culture, but I'm just wondering if you could speak a little bit to the architectural and or site context. There may not be much architectural context, don't know, but it seems like an appropriate expression, but would just like to know a little bit more about what the problem was you were solving in that regard.
The site context and surrounding architectural context in the area, we were sure to look towards some other low-income developments that both the Rosebud Native American tribe is in the works of creating and constructing right now, but also surrounding tribes. So when we were taking a look at that, we were referencing the materials of the downtown area and then the construction methods of the other developments that are in the area as well.
Thank you.
Looks like we still have a few minutes if anyone else has questions.
Sure, I'll add to that. I always think it's nice when teams can actually do some interviewing with members of the community, and it would have been really nice to kind of spend some time talking to tribal residents or just trying to get a sense of what they're looking for in their communities. I don't want to make assumptions, but maybe some more community space or educational space just would have been an interesting touch. Did you get a chance to, I don't know, do any studies with the residents that you were targeting?
We did not, no. Our information on the tribe and the clientele that we were building for was based off of the tribe's website as well as Mission South Dakota's community page online.
Any other questions from the jurors? No. All right, thank you, Kansas State, for presenting. Next up, we will have University of Central Florida presenting at 11:30 a.m. So we have a few minutes till then.
Intersecting concepts, community, climate, and cost. Moving to the location, as you might have heard, Florida is well known for its hot and humid weather, and St. Petersburg is not an exception. Addressing cooling solution was a high priority when developing our design. Looking closer, this approximately 50-year-old apartment complex is located in the historic uptown neighborhood with easy access to multiple transportation methods and amenities. Within this area, 80% of the homes were built before 1980. Moving into the architecture, Fair Oaks apartment contains 6 one-bedroom units and 2 two-bedroom units on 2 identical floor plans. Our architectural goal for this design was to create an affordable, energy-efficient building that blends with the neighborhood and addresses residents' concerns. Fair Oaks apartments will match the neighborhood colorful aesthetics with its new blue and white color scheme. And to break up the exterior, Bahama shutters will add dimension and decrease the summer heat entering the building. One of the residents' concerns we addressed with our design was a feeling of separation between apartment renters and single-family homeowners. To address this, a community garden and terrain cover area have been added near the sidewalk to encourage conversation between neighbors and add opportunities to enjoy the outdoors. The engineering section comprises of 3 main parts: HVAC, building envelope, and water management. We opted for a multi-zone mini-split ceiling cassette unit to cool and heat the building. This system works with an inverter technology that allows the units to regulate the amount of power and refrigerant flow to the indoor units thereby reducing energy consumption of this equipment about 40% in comparison to conventional units. This system has a seasonal energy efficiency ratio of 20.1, and it offers excellent aesthetics, ease of maintenance, and is equipped with an intelligent thermostat and sensors to control the condition of space better. The building envelope consists of an exterior insulation finishes system with modular application, R value of 20, a metal standing seam roof including field celluloid R45 insulation, and highly efficient insulated impact-resistant window with a U factor of 0.2. The exterior insulation finishes systems allow for a reduction in installation time and provide excellent resistance to heat flow. In order to lower water usage of the house, we collected rainwater from the roof and stored it in underground tanks. We then use this water for high-tech irrigation systems as shown in the pictures. Sprinklers and bubblers are automated and their time work can be set by the user on need. Also, high-efficiency toilets and faucets were implemented, lowering total household indoor water use by about 30%. Moving into durability and resilience. The durability and resilience of the building show its longevity. Certain components make up the exterior of fair oaks, such as a standing seam metal roof that can withstand intense conditions lasting more than 30 years. External insulation that can take most impacts with a stucco finish that is easily maintained and repaired if when damaged. And finally, the impact-resistant windows hold up to all Florida weather conditions while keeping the residents safe. Moving into integrated performance.
3 main additions make up the overall integrated performance. Firstly, a new mini-split high-vac system cools the building off quicker, along with the help of added insulation and windows to help it cooler longer. Secondly, solar panels are used to generate energy on-site to help run appliances. And finally, rainwater is collected and stored to use for irrigation. Moving on to occupant experience. The new occupant experience started off with upgrading energy-efficient appliances, adding new carpeting, and new casement windows to allow for natural airflow and abundant daylight savings to enter the units. Adding community areas such as picnic tables and gardens give spaces to residents as an outdoor area for recreational purposes. Moving on to comfort and environment. To mitigate the presence of chemicals, dust, pollen, biologicals, and moisture, the indoor ceiling cassette is equipped with a powerful 5-step air purification system that removes odors, germs, and fine dust. To treat humidity, the multi-zone indoor units include a dehumidifying operation mode. In this mode, the unit's internal sensors monitor temperature and modify the set point and fan speed to remove moisture from the air. The use of ventilation fans for bathrooms and cabinet range convertible hoods for kitchens are strategies of spot ventilation. These systems remove odors and moisture from the space, while the noise level is low compared to older models. Moving on to energy performance. To increase the energy performance of the house, we reduce energy uses by adding occupancy sensors, installing a standing seam metal roof which has high solar reflectability, and replacing line fixtures with LEDs. The solar panels consist of 26 kilowatt monocrystalline panels. These produce 40,000 kilowatt per hour per year. They save $5,500 per year, and they are also co-compliant with on-grid systems with fuller regulations. An open-loop 5-ton geothermal heat pump system was added to provide hot water to half of the units. When looking at the HERS score of this building, it was initially 100 in 2006, which is after making minor changes to the building, it was brought down to 49. And with the addition of renewable energy, the HERS score reaches less than 2, with an EOI of 49 kilobutane per square foot per year. Moving on to embodied environmental impact.
For the environmental impact, the team sought to provide housing solutions without the impact of clearing land or new construction. In addition, due to Florida's climate, our goal was to find durable and hurricane-resistant additions or replacements that reduce the apartment's environmental footprint and wastage generated in its future life cycle. With the new changes, there was a calculated carbon emissions of 40 tons per year. Next, for the financial analysis of this project, the expected budget was calculated based on US and local market prices and was estimated to be about $348,300, including additional costs such as labor and installation. Finally, for the market analysis, the solution to afford the calculated budget and to meet the market value of the area while also keeping it affordable, we decided to slightly raise the current rent prices for each of the units by about $300 per month. And with the new profit made from the new rent prices, plus the savings that the solar panels will supply to the building, we average about a 10-year period for a return on investments on this project. And this was the Fair Oaks Apartment Complex retrofit. Thank you for your time.
Thank you, UCF. We can now move on to the Q&A. Melanie, would you like to start us off?
Thank you for your presentation. I thought it was a great project, and even though you were kind of constrained by your retrofit, I think you actually came up with a nice kind of elegant solution, and it does make it look more like a tropical unit, and I appreciate that. I was going to ask about, I saw that you were trying to be a little bit sensitive to the renters in a owner occupied neighborhood. And I think that's really a nice extra touch. And I was wondering, is this zoned for kind of high density and low density? And could this project potentially be replicable in other neighborhoods as well?
I can answer that. So in this neighborhood, there's a very eclectic mix of mostly single home families, but a lot of these have been converted into like duplexes or rented.
Right.
And then there are quite a few just more high density multifamily units. And so this is by itself a unique building, but one thing we want to show is that for these units that are being rented, like there is no need to demolish. You can improve them, you know, make a profit, and while also like because these units were so aged, the building owner kept rent lower than market value to kind of compensate for that, like less of an occupant experience. So by just raising it to the same price as the similar units that are not retrofitted, we can kind of keep it more affordable so people can access these types of high-tech homes, while also, you know, making a bit of a profit that we can use to fund these improvements. So it's not just coming all out of her bank.
And I think your presentation was unique in taking those considerations into mind, and I applaud you for that.
I love your project. You know, I agree with you. It just sort of looked like Florida to me when they were done with it. Yeah. And so I think you did a great job, and it's a challenge when you're working with an existing building. And so I love that. I thought your upgrades were common sense and very appropriate for the building and for the climate. I liked your life cycle analysis and O&M analysis. So if you're an owner, you want to see what the recurring expenses are going to be. And I think you did a great job on that. I wondered in your wall section, I missed a weather resistant barrier. Maybe I missed it. And maybe coming from a cold climate, I don't know anything about a CMU wall, but it struck me that there probably needed to be a WRB in that wall section. Did I miss it, or?
Devin, would you like to speak to that?
Yeah, so in the IF system, it's built in to protect from the environment. So there's a drainage system and protection from the elements. So we should be good on that front.
So repeat the first part of what your answer was. I missed that.
Oh, sorry. So the IF systems that we're putting in, they come with a drainage system and barriers from the elements from the outside. So we should be good from anything that can come in and cause harm to the building.
So, and I'll add to that to give a more explanation of the finished system, of how it's operated. So we got a moisture barrier. I think that's what you're referring to. And then we got the insulation EPF foam board. And then after that, we got the reinforcing mesh. And then that's where we get the stucco. So when we refer to the finishing system, it's all in one packed.
Okay. I liked your approach with mini splits. I'm skeptical that you need 2 of them per unit and that you need to zone them for the size of these units. I think that was probably overkill. But if you have a comment on that, I'd love you to defend that, I guess.
Yeah, sure. So we use it for a multi-zone because we have, you know, they're separated, and to be able to accommodate for the occupants, the best solution is to divide the units, the ceiling cassette units. The cost for them, it was not dramatically high in comparison to other units. So we thought a lot about the renters and people are going to be there in terms for comfort. And it made sense to have individual cassette units in those space, and they can control the spaces. If they're in for example, the room, they can shut down the one in the in the living room and save energy that way. One of the main uses for mini split and the advantages is because it allows for that, to be able to divide the cooling spaces. Whereas if you have the ducted system, you got one thermostat in one place. And then in here, if you have a divided system, you can control the spaces, saving energy and having a more comfortable space for the renters.
Yeah, in addition to that, not defending the two units, but replacing the ducted system. Currently, how it's laid out is that the machinery is basically in your closet and it's exposed. So you're moving your clothing right next to this, kind of dusty machine. So that was something we also wanted to address with our added changes, is to make it a little more comfortable for them, and so they can have that closet space back.
Hi, nice job, guys. I would echo the previous comments. I think it's a very solid project. I think the architectural enhancements seem appropriate. Obviously, you're at a little bit of a disadvantage doing retrofit housing relative to new housing in terms of being able to be real expressive with the architecture, which leads me to one of my questions, which would be, I'm curious to know more about your team makeup and whether or not there were architectural students as a part of the team. So that would be question number one. And then question number two, entirely different, but sort of along the lines of what Jean was asking about. I'm curious to know more about your air tightness strategy. So you had a WRB formed through the EFS system, but air tightness is also very important, and keeping water out, of course, is number one task, but air tightness is a close second. So curious to know more about that. So.
Yeah, Dione, would you like to address that?
In terms of the air tightness, we believe that just with the finishing system and the windows will be enough for the units based on the cooling load and analysis that we made. We thought it was appropriate. We didn't want to go over it, putting a lot of stuff. At least that's what was one of our concerns. And we thought it was appropriate just with the finishing system, and the implementation of the new windows will cover for that part.
And as for the team makeup, we're all mechanical engineers. So this was a really big learning experience. Got us all out of our comfort zone.
Yeah, so maybe two comments followed up to that. So one, I think you did a really great job with the architecture, considering that you didn't have an architectural team member, but I would also encourage you to try to integrate that. Just like I would say to architects, me being one, that it's important to integrate engineers, I would also say from an engineer standpoint, it's important to integrate architects and take things to that extra level. I would also encourage you to look into air tightness. It is very important in all climate zones, particularly in colder climate zones, but I would encourage you to look into it, because EFS alone will not do that for you. It can potentially, but look into that. So yeah. Thank you.
One point to add, because we were mainly mechanical engineering, we decided to find the HSK architecture company that we had meetings showing our work, and we got their ideas how we can improve the architecture of the house without having like very extra cost causing and still keeping the rest of it.
Yeah, so I'm also very impressed with this project, and I especially like the emphasis on developing community spaces. Provided you can get rid of the insects, you can sit outside, right? I'd be interested to see what you guys did with insect protection. My question is about, well, one about resiliency, right? So you've insulated the envelope, you're keeping heat in or out sometimes, but what happens when the grid fails, which in Florida, does happen.
Yeah, so I can speak to this a little as well as Dio, but the current roof structure is not tied down according to Florida code. It was built before that was integrated. So that was one of our main issues that we wanted to address, was to making sure that when we were replacing this roof, we are adequately protecting it from hurricane force winds. And especially because it's a metal roof, that will also help protect, again, from impact damage. And that's kind of the trend of where the neighborhood's going. And so that kind of incorporated the neighborhood as well. And then for the windows, we made sure to, they're original windows currently. So we're replacing them with impact proof windows so they can withstand those hurricane force winds and debris. And then Dio, do you have anything to add to that?
I believe the entire point of the external changes were to make it permanent in a sense, to where we wouldn't have to change it in 40 to 50 years, which is why we chose a metal roof and the impact resisting windows, because you usually don't change windows like 20, maybe 20 years, 30 years. Oh.
Well, so my resilience question was not about what happens during a hurricane. That's a good point you made. That's a good point. What happens in the aftermath, right? Is I keep talking about the grid, but the grid is susceptible to these problems, right? So what happens when power fails?
So that's one issue that we had to struggle with, is in Florida, we are not allowed to completely isolate our grid, and especially as an apartment complex, because then our apartment owner would be like basically serving as a utility and needed to be managed by the state of Florida. So that kind of puts us in a very complex situation. So that's why we didn't incorporate any like power battery systems or anything like that, because we were worried about having conflictions with that state regulation. And then
Wait, so you're not allowed to store your solar generated power?
we were concerned about storing and then distributing to units and that being perceived as like charging. Yeah, we just were very concerned about that. We did not want to step on any toes and put our homeowner in trouble. So, and then additionally, we're basically 2 blocks away from a hospital. So their grid connectivity gets prioritized very fast. And so that's something that the neighborhood overall benefits from, is that unless it's like a power pole, like right next to your home, like if it's overall connectivity, like it gets put up pretty fast.
Excellent. Thank you.
Lucky.
Yeah, I know.
It's very
Actually, I did have can I ask another question? Okay. One of the things that it sort of doesn't really occur most of the time to most people is that when you have a hot and humid climate, right? Your biggest climate change issue, of course, is the wet bulb temperature, right? Your humidity plus heat going up. So that's really damaging for human beings, right? But it's also somehow damaging to your building, because when you have cooled interiors, you end up cooling the surfaces. And then you're saying people want to open windows because it's pleasant, and all that moist air rushes in and condenses on that. And in a strange place, I saw this in real life, was in Dubai of all places, which is a very humid place, believe it or not. So what did you guys sort of think about that problem?
I can answer that. So that really isn't an issue for an apartment, but if it was, there's like specific paints we can use on the walls inside that prevent like bacteria growth and moisture growth to affect the insides.
Yeah, and I
That's
think the system also addresses this. If you would like to speak up about that. But yeah, we think our AC system would be able to address that. And we've talked to the homeowner, and mold growing in the interior has not been an issue previously, even with residents that do open their windows. So that wasn't a large concern that we think that the original structure already has that kind of, figured out.
So I was going to ask about the metal roof. I think it's a great idea from the resilience standpoint and the hurricanes and it's longevity. I assume you took that cost into account.
Yes.
Okay. I was also going to ask about flooding as well. Did you do a flood analysis of the area?
Yeah, so we're 36 feet above sea level and in a non-evacuation zone for if hurricane force winds push, because we're right by Tampa Bay. So the high winds will empty that out or push it in. And so we are not at risk of flooding from that. Yeah.
Well, think about street flooding too. I know from personal experience. Sometimes you're not on the flood map, but you can still flood.
Yeah, we're also 3 feet above our sidewalk as well. So, and we got brick streets, so that kind of helps absorb.
Interesting. Yeah.
All right, thank you, UCF. That was a great job. We'll be breaking for lunch now, and we'll reconvene at 1:30 for University of Arizona.
Okay. Thank you.
Thank you. Thank you.
A great soul to come by.
For the University of Arizona's Attached Housing Project. Teachers Row is a project located in Tucson, Arizona, and a crucial component of our greater energy network, the Sunblock. Our team consists of 4 undergraduate architecture students.
Tucson, Arizona is nestled between mountain ranges in the southwest Sonoran Desert region of the U.S. with a population of 540,000. It is in the hot, dry climate zone of ASHRAE 2B. The summer is extremely hot and can get near freezing in the winter, with 3 months of high humidity and rain during the monsoon season. Miracle Mile put Tucson on the map as the automobile gateway into the city, where motels competed for visitors with large, distinctive neon signs. Our proposal seeks to celebrate the history and sense of community in the neighborhood.
In Arizona, the average income of teachers was just above the line for housing assistance, excluding them from funding programs that could help them own their own home. Teachers Row provides housing for new, current, and aspiring educators while helping establish these teachers in the communities that they serve.
With the help of the City of Tucson Housing and Community Development Department, our purchase model would require the city to donate the land to the Pima County Land Trust, which would own the land, construct the houses, and be in charge of selling the units. To ensure that the units are first offered to teachers, the Land Trust would place title restrictions on each unit. With this land trust model, the buyer purchases the structure, not the land that it sits on, keeping it affordable.
There are 7 units of 3 varying sizes enclosed by a solar array system showing the average energy consumption, commonly known as the duck curve. The building opens up to a green space along the north facade, and staggering on the south facade provides an opportunity for self-shading. We converted the existing motel into a space specifically targeting the needs of educators, and more will be covered in occupant experience.
The unit size and division was determined by our initial conversations with our partners in the U of A Pathways to Teaching program and current educators in the Sunnyside and Amphitheater School District. Each unit has an ADA compliant bedroom and bathroom on the first floor, and the second floor consists of bedroom and flexible space, or 2 bedrooms based on the unit type. The mirroring of plans allows for similar room functions to share common walls between the units, aiding in acoustic control, and centrally located MEP rooms allow for simplified mechanical, electrical, and plumbing plans.
The configuration of our secondary roof structure responds directly to the power generation mismatch between the power that's being generated and the power that's being consumed. Our photovoltaic superstructure acts as a visual representation of this problem while physically acting as a solution. Aside from the educational aspect of the PV structure, its aesthetics also pay homage to the distinctive neon sign seen in the Miracle Manor neighborhood.
Thanks to our solar panels, the energy runs an air-to-water heat pump that chills or heats water using the minimum amount of refrigerant. Thermal energy is stored in underground tanks and moved to ductless air handlers through water pipes. Furthermore, using the same thermal storage tank containing hot water, we can run a secondary water line that supplies hot domestic water to all our units. A 30-gallon electric water heater is a buffer and a backup tank to ensure we meet the user's water needs. To ensure proper ventilation, an energy recovery ventilation system is put in place in each unit.
The building is made up of prefabricated wall and roof panels from our partner B Public. Within these panels, wood is the primary structural component. Dense packed cellulose acts as the primary thermal and acoustic control layer. Plywood sheathing with tape seams acts as a vapor and air control layer. And a factory installed membrane acts as a secondary weather resistive barrier. The facade of the building is clad in recycled aluminum metal panels, and the pressure equalized rain screen acts as the primary water control layer. Insulated operable aluminum louvers and double pane windows break up our facade. We kept concrete footings to the perimeter and eliminated a traditional concrete slab. Instead, we utilized 2 layers of plywood, glued and screwed together, placed atop a vapor barrier integrated with the control layers of our B Public walls, and supported by 2 layers of compacted gravel.
What Sophia just mentioned was a very important step in minimizing the embodied carbon of our project. We looked at a lot of ways to reduce the footprint, but one thing we did that really mattered was eliminating the concrete in our slab.
we were able to reduce the CO2 being released from our project by 51 tons.
One of the biggest challenges we have in Tucson is an ongoing drought. So we used water conservation and harvesting strategies to reduce the amount of water our building needs by half. The water collected from our roof sustains the native drought-resistant plants, and the building itself utilizes water-sense appliances.
Our energy model shows that the PV system makes far more electricity than the building needs. If there's a blackout, 5 Tesla Powerwall batteries store enough electricity to get the occupants through the hottest summer day. Teachers Row is connected to a larger district energy system, the Sun Block, and works with the 2 other projects being presented by the University of Arizona here today. The 3 projects in this system all produce a surplus of energy and have the capacity to give it back into the Miracle Manor neighborhood.
Our solar array superstructure creates energy, but also serves as a shading device. From this system, we can also power the Chiltrix, creating thermal energy, which is used to condition the homes. The water tanks holding the thermal energy are filled by rainwater collected from the roof. To further ensure comfort, the operable insulated louvers work in tandem with the solar chimneys to extend the seasons when air conditioning is not needed. We have kept the duct and pipe runs short for efficiency and consider acoustics in our design.
Running an energy analysis in WUFI, Teachers Row was able to meet the FIAS 2021 performance criteria. We recognize the B public walls and roof are overperforming within the 2B climate zone, so we ran a second energy analysis with R values closer to code for those components, and our design still meets the FIAS targets. Thermal bridging in the B public panels is close to non-existent due to OSB and the web truss having low thermal conductivity. 2/3 of the photovoltaic panels face west, while the remaining third face east in order to shift peak production hours. The photovoltaic system is able to outperform traditional south-facing panels by 21,337 kilowatt hours per year. The peak demand hours between 2 and 6 p.m.
Understanding that throughout the year, the building units primarily require cooling to ensure the comfort of the users, the air handlers were placed on the ceiling, allowing the air to cling to the ceiling before dropping, distributing the air with less energy and more comfort. Windows along the north and south facades promote well-lit interior spaces, and self-shading along the southern facade helps prevent direct solar heat gain.
Residents of Teachers Row occupy homes that have been designed to respond to modern demands identified in the field of biophilia and health regarding access to exterior views, adequate exposure to natural light, and clean, fresh air circulated throughout the building. With the COVID-19 pandemic greatly shifting the needs of educators, our conversations with our partners in the field highlighted elements that can provide more support to teachers in their own homes. The existing motel on site is redesigned with private office spaces, a shared computer lab, a reading lounge, and a children's play area, all with the goal of meeting specific needs the teachers face while working from home.
Teachers Row aims to remove the fear of not having a secure home for those in the education field and helps establish the teachers in the communities they serve, highlighting the importance of education. We envision Teachers Row as a hub for the Miracle Manor neighborhood, a way to engage the public via bright colors and neon lighting, just like the historic Miracle Mile did, and a way to educate the community on the importance of energy consumption. Thank you.
Thank you, University of Arizona. We can start the question and answers. Jean, would you like to go first?
It's a beautiful building. I love this, the concept and the fact that you got the duck curve in there. I mean, seriously, is that poetic or what? So I think it's a really great project. I think your presentation was really good. I think of all of the narratives that I can remember now, it was the most readable, and yet still really along the way giving us all the facts we needed. So great job on presentation, and then the model is terrific. Did I miss a lot of the energy analysis, life cycle analysis, all of those things on the motel building? Is it in there somewhere and I missed it?
No, so it's worth noting that we started this project midway through January. So due to having to finish this for the semifinal and then iterating on it for the final, we didn't have the time to complete that analysis.
Got it.
So, but it would be the next step.
I thought the idea of saving the motel was probably a really great idea, because there's a lot of embodied carbon already in that structure that they get to reuse. And I thought your sensitivity to the occupant needs was great, because you were thinking through, well, what can we do with that motel? And, well, we've got a lot of uses for that. So I applaud that.
Yes, excellent presentation, guys, both in person and the submittal beforehand. I really like the duck curve metaphor and expression. It's just brilliant on many levels. And you mentioned some of those levels it speaks to. So great job with that. Also like the incorporation of the Be Public system. I think those guys are doing some amazing things too, and plugging that in, and how you treated those made them far more interesting too than they might otherwise be. So I'm curious about a couple of things on the more technical side. You spoke to it a little bit, but like I told one of the other panels earlier, they did an amazing job with the architecture, even though they didn't include an architect in their team. You guys have done an amazing job with the engineering aspects, despite not having an engineer on your team. And so I'm wondering about if you could speak to whether or not that opportunity was available, and if you and how you chose not to go that direction. I think it's very important to integrate that. And then on the more technical side of things, you went with a air to water heat pump. And I'm just curious to hear about your choice of that versus air to air or others.
Just to clarify with the first part, you're asking why we are an all architecture team. So we're actually offered the Solar Decathlon as a studio in our architecture program. So it's just offered to us architecture students. We didn't pull any other majors or anything in, just wanted to kind of keep it to us and utilize like our industry partners to like strengthen our knowledge when it comes to all these other topics. And we just kind of keep it in architecture. Yes.
I will add that we did reach out to structural engineers, mechanical engineers, civil engineers for all of these, all of these aspects. So also the fact that it's to our studio only, bringing those engineers and business people, it was hard for them to get the credits they would, for school. So it wasn't worth it on their end. So, but then to answer your second question about the air to water heat pump, really it came down to how much easier it is to move water as opposed to move air through, in our case, it's ductless through water pipes. It's much easier, requires less energy. So that was the main reason that we selected the air to water heat pump.
Thank you.
It's me, I guess. Yeah, I love this project, and I especially like the use of native plants outside. It's this it gives a really my own parents' house is similar, and it's really great to walk out and see plants, right? And to even have inside. I'm interested to hear your thoughts a little bit on maintenance, right? Fantastic stuff on there. Yeah, complicated solar roof, beautiful but complicated, right? What is the plan for maintenance? Who's going to look after all these cool new things you're going to put in there?
So, like we said, the land trust owns the property, owns the land, correct? As far as the green spaces, the motel, they would be in charge of keeping that up. The units themselves, the owner would have to reach out to their homeowner insurance to try to, if anything happens that breaks that needs fixing, it will be through them. The solar array, that actually is owned by Tucson Electric Power Company, so they are in charge of that.
Cool. Thank you.
Yes, great job. Very kind of aesthetic solution to this problem, which is a nice extra bonus. And I appreciated that you thought about the work experience as well. I mean, I would have loved to have another place to go to work in a pandemic that wasn't, my second bedroom. You get a little sick of that view all the time. So I appreciate that. I was actually had a question about sort of what you see here. I know you alluded to the neon sign and the character, the fabric of the neighborhood. I see that it looks like the solar arrays lit up. Is the facade also, is there lighting, colors? How did you respond to the neighborhood?
Yeah, so the electricity that's being generated by the solar array, that is what lights the neon and the rest of the LED lights. The neon is like LED, but it's replicating that motel
Mhm.
and the historic mobile motels. And the projections that you see on the facade are actually like floor lamps that project that light
Okay,
onto the
cool.
facades. I don't know if you guys are familiar with a French word that our advisor Jonathan Bean introduced to us. It's daily tous les jours. It's something along those lines. But they did something where they incorporated like a light installation along the facade of their buildings that actually is very similar to that, but horizontally. It's like a multi-story building. And so as people are walking through that neighborhood and they have a green space as well, and people are physically looking at that, I'm assuming the hope is it sparks curiosity.
Mhm.
Those conversations are had and the knowledge is dispersed amongst the community. So that's what the goal is for that.
So what material were you guys thinking for the actual cladding? Is it a metal?
Yeah, so the actual cladding is recycled aluminum metal
Okay.
panels from CPI materials. But then the lights that you see actually on the facade aren't attached to the panels, they're projected up onto.
Got it. Very interesting.
So I get that the panels themselves are the power company. Is there net metering or how does that, they own them? How does all of that work?
Yes, so we touched on the topic during the presentation that we are part of a sunblock system. This idea where the whole neighborhood is sharing thermal energy, right? In our case, the solar array structure is owned by Tucson Electric Power Company. Every solar panel has a microinverter in them. We are running that power into the Tesla water batteries and then into the water tanks to create that thermal energy. From there, we're moving the remainder of that energy onto a main site that is a much bigger tank for thermal energy that is going to be distributed to the houses in the sunblock. And the sunblock is the Miracle Mile neighborhood.
Well, I noticed I didn't see any cost data for the actual, looks like a steel or aluminum structure.
It's a combination of both.
And so Tucson Electric's really going to pay for that, or is that a miss on your cost estimate?
No, actually, the Tucson Electric Power Company is looking into creating these micro farms throughout the city. So that's something that they have recently started to invest in, and we haven't gone down the steps of creating a cost estimate for that, but they are on board on the idea of creating these micro farms through neighborhoods, minimizing the strain that we put on the electrical grid in Tucson since it's pretty outdated.
I think some diagrams maybe explaining that would go a long way to, yeah.
It looked like a
Jumping.
big vacuum in the
budget.
Yeah, it looked like a black hole in the budget to me. I was afraid it was going to blow the economics of the whole deal.
And it's worth noting that the cost estimate, it's purely on the building, right? We're not charging that superstructure onto the TV.
I would defer time. I have a couple of quirky questions, but if somebody else has got a more pressing question.
It's also not a sensible question, so go ahead. I can ask my,
yeah.
Go ahead.
I have one sensible
question.
Go ahead.
Maybe you go
then,
first then, yeah, go.
I'm getting good at this microphone.
Yeah, you're MC.
Took me a while.
And maybe the panel can weigh in on this too, actually. So you said something about the east and west direction of the solar array being better than the south, better performing. I was just wondering, how is that possible?
Yeah, let me clarify there. Overall, year round, it is not better. We're actually producing less energy, about 35,000 kilowatt hours total. But in our case, knowing that educators are not going to be using the space between the hours of 8 a.m. to about 2 p.m., our goal was to shift that energy peak production to the afternoon. We are doing that. We're shifting the production to 2 instead of 12. And we are producing about 22,000 kilowatt hours of energy more between the hours of 2 and 6 p.m. Year and during the year.
Interesting.
Yes, actually, my not sensible question is related to that, which is the duck curve you show.
Yes.
I thought that was from California. Does Arizona actually have the same level of problem with overbuilt solar renewables energy, which creates this peak and you have to get peaker plants online?
Yes, the problem does also exist in Arizona. We actually, to get that one curve, we used it was an energy analysis system by NREL to get like the peak to the radiation hours, like hourly for a day throughout a series of days throughout the year, and it produced pretty much the same graph, and that's what we showed. that's what it's modeled after as well.
Still more time?
Yeah.
Still have 3 minutes.
So this is more quirky than yours. In one of the units, and I made a note of it here. The upper north bathroom unit I saw on the plan. Specific, if you have that ability. I didn't see it show up. But there is it looks like a deliberate, it's more of an overall floor plan if I remember right. But there seemed to be a deliberate effort to have all the plumbing back up to itself.
I can see that, yeah, the toilets are back.
But there was one toilet that was opposite and it seemed deliberate. So I wondered about that.
So she says a quick question, and I think I have to give you a quick answer. In typical architecture fashion, doing an all-nighter.
25 or 6 to 4. Yeah. Yeah, okay. It's a quirky answer for sure.
That was just a mistake on our part.
Okay. Okay.
Well, it's a deliberate choice.
All right, unless there's more questions. Thank you, University of Arizona. That was wonderful. We'll have Wentworth Institute of Technology presenting at 2 p.m.
Nice job.
beatboxing in the background? Right. Yeah. Okay. Fair enough. That's part of the presentation.
All right, you can start presenting.
Good afternoon. We are representing Wentworth Institute of Technology in the Attached Housing Division. Our project, Solar Garden Apartments, is located in the neighborhood of Mission Hill of Boston, Massachusetts. Our team consists of myself, Jordan Ansperonis, and my partner, Skylar Chardon. We are both currently in our 4th and final year of the Wentworth Architecture program. We worked with a team of 4 consultants specializing in wall assembly, construction management, mechanical engineering, and market analysis. These are the 9 categories that we have used to organize our presentation for you today. Our project, located in the heart of Mission Hill, is within a close proximity to many reputable hospitals and universities. Our group investigated the typical Mission Hill house and broke it down into 3 design constraints: rule of thirds, framing and facade, and shared exterior spaces. In 1950, census concluded that less than 7% of residents in Mission Hill had a college degree or higher, compared to the national average at that time, 8%. Currently, over 50% of the residents of the Mission Hill neighborhood have a college degree or higher, compared to the national average of 37.5% in 2020.
So moving on to our climate here in Boston, at the top right, we actually have an elevation map showing obviously Mission Hill being a hill. We have our site at the bottom of that slope, so that's pretty nice. And at the top left and right, we have multiple layouts of different climate information over the past year in Boston, kind of see comfortability and with the graphic off. Then moving into our conceptual perspectives here, we really want to have this journey through not only the park on the left, but the street of St. Alphonsus, and then coming ultimately to this church piece connected to the landmarks. Here looking at some site context. On the left, we just wanted to show our building height in relation to the rest of the context around. And then on the right side here, we have the context in terms of building height and building age. So the dark would be the more newer construction.
Our goal with our design is to connect the entrance of Kevin Fitzgerald Park to the Mission Hill Basilica. We started by allocating our geometries on the site based on existing site context. We began to shift our buildings to create this pedestrian path in the center. And by offsetting our levels, we were able to really get those exterior spaces. Our units our groupings are considered consistent of 4 units, a larger unit of 3 stories, a accessible unit, and then 2 two-story walk-ups, totaling 8 units on the site. By laying out our units, we are able to create a comfortable experience for pedestrians of Mission Hill to walk through. This is a sketch perspective that allowed us to investigate the usage of materials and framing of our geometry of our building of the sites.
So here we're looking at our first floor plan. We are doing with an open concept in terms of the accessible building, very accessible unit. You can see that on the top right. And on the bottom left, we have our 3rd story.
Here we can see the open concept floor plans of the living spaces on the 2nd floor. And a typical master bedroom and bathroom layout on the 3rd floor.
Here we go into our electrical, plumbing, and HVAC systems. We have a pretty typical electrical layout throughout the entire building. Our plumbing has mainly shared wet walls, so we're trying to have more efficiency there. And then in terms of our HVAC and the rest of our mechanical systems, all of that culminate into the top right where our mechanical shaft would go all the way through the building. So here we have our elevation, kind of looking at the tones and materials that we chose to use. These are pretty representative of what Mission Hill's been dealing with currently, so without offending the aesthetic. Here looking at St. Alphonsus on the back side of the elevation, you can also begin to see where Kevin Fitzgerald Park kind of favors this there. I'm looking at some of our sections here on the top. We have a section cut through St. Alphonsus. We're looking at egress here and how our floors begin to relate. And then on the bottom, we can cut through the entire thing and seeing how that really important courtyard space is being created by the geometries of it. Here we're looking at some of the sustainable material choices that we went with. Our recycled siding, reclaimed wood flooring, and specifically recycled steel beams for our structure. Here looking at a mechanical section perspective, we cut this through the mechanical shaft, being an important part of the building. Then we have the green HVAC and the blue plumbing. There would also be access up to the roof, so all the solar panels that are on the roof would be main leads every time that would be needed.
Here we have our sprinkler system layout, which utilizes our rainwater collection. Our solar panel layout of 181 solar panels and a slight slope of our roof for our rainwater collection.
Here we have our HVAC layout and how that connects back into our mechanical shop. We have one air conditioning unit per grouping, so there's going to be 2 total also.
Here we have our water system and diagram. Our rainwater collection, 191,000, is projected to do 191,000 gallons per year, while we use 120 gallons per year, 1,000 gallons of water per year. Here we have a rendered view of our recessed LED lighting to show how the space is illuminated when sunlight is no longer available.
Here moving on to our wall assembly. So the actual wall itself would have an R value of 50, while our roof connection would have an R value of 80, and then our typical concrete slab with the radiant flooring with the ground connection would have an R value of 30.
Here we have our 4 typologies of our window layouts using low EIG custom windows, a solar heat gain of 0.24 and an average U value of 0.27.
So here we took our massing and ran that through heat, and we were able to obviously identify that the roof's going to be the best place to place the solar panels, and that also helped with the allocation of our building. So with those 182 rooftop panels, we were able to get roughly 1,300 kilowatt hours per day.
With a HERS rating of -1 with the PV panels.
Here we have some of our market consultant actions in the Mission Hill area specifically. And that kind of led him into some of the estimations of our project costs. So our total project cost for everything on the site would be 6.3 million. And then if we were to sell everything, that would be about 7.2. And this is before if we were to rent anything out or have anybody living in the spaces.
Here we have some exterior spaces, pictures of our space. So you can see the framing of the church in the foreground, what it would look like looking out some of our windows. And then here's another perspective from the first floor. And thank you guys.
Thank you, Wentworth Institute of Technology. Let's start with the Q&A. Greg, would you like to go first?
Sure. Very nice oral presentation, guys. And slides. You covered a lot of ground in a short period of time. Impressive. I also really appreciated the attention you gave the context, exploring what was there and how to best respond to it. The rule of threes, I think, is a nice tie to the neighborhood. I think it's really important when we as architects make moves with form and complicate the forms, that we do it for good reasons and with good thinking behind it. And I think it really creates some interesting spaces. I'm curious to know if you did any sort of modeling or analysis of the impacts of that on performance. I saw you had the inclusion of the solar aspects and how it affected your PV performance, but curious to know if you did any modeling on the buildings themselves. So,
well, we originally had like a wood frame system for our structure. So that obviously, with the elongated spans and everything, that kind of took a lot out of our, net zero impact and efficiency in general. So that's why we went to the steel beams. But then in terms of overall efficiency, we really went through heat, and that was pretty much our biggest kind of solar, I would say, efficiency cap.
Other than our rainwater passive collection system,
right.
I would say solar panels are our main focus of our energy and kind of really bringing this building.
Right. So yeah, I really like the concept of the concept in general, and I appreciate the fact that you tried to preserve the walkability through the site, because I think that's important. You know, you just try to close everything off. It's not great, and try to connect to the existing historical. My question is about sort of, I missed a little bit about sort of resilience in extreme weather. You know, Boston is almost famous for extreme weather. Right? And yes, you do have insulation and stuff. Obviously, you can't do without that. Can you talk a little bit more about what are the plans? What's the resilience measures in place for that?
Yeah, so I think our custom windows are big on that when it comes to utilizing sunlight, but also keeping out the heat with the low E ratings as well. Our durability in like the siding itself, the reused recycled siding is important, especially in Boston, because you kind of see a lot of wood siding, it starts to tear and you have to start replacing it. So making sure that the resilience of that with the weather of the rain and the sun and the snow is very important with us with this project.
We also had a wall assembly consultant, so our actual wall assembly was really important. We went with a double studded wall, so we thought that would be more capable of being resilient to, obviously there's going to be snow, rain, wind, sleet, all of it's Boston. So we thought that having a double studded wall may make it a little bit more rigid.
So I think one of my questions probably got answered through some of the renderings, actually. I think it's nice that you had a very intentional kind of pathway through the middle. Can you, it seems like it kind of views the church that's, or it frames the church, that's what you were going for? Okay, that's a nice touch. And I know in some of your renderings, you had some beautiful like window views. I would have played those up a little bit more, like make it look even more enticing. Related to the question about resilience, it looks like your solar panels are on a flat roof.
They are on a very, very gradual slope.
Okay.
It's like a 1 inch to 5 foot slope.
Okay.
Very, very slow.
So are residents expected to kind of shovel off their roofs, or how are you going to deal with that?
So giving access up to that space, we're planning to have like maintenance men be able to come up there and not only change the solar panels in and out, but potentially bring solar off of that space.
Yes, with Boston being, it does have snow, like you said, so snow removal is very important. And that's why each solar panel, the layout has access to every single solar panel.
So as I've said previously, I'm the lousy builder on this panel, and just a couple of comments that maybe I'm not understanding, but we build with a double stud wall all the time. And the point of it is to fill that cavity with insulation. And I think you'd use an air gap. And I think that's a real missed opportunity to go to the extent of doing the double wall and not really taking advantage of that volume space. We build 3-story townhomes every day, net zero energy 3-story townhomes. And I just cringe that we're using steel for a 3-story structure. And I think I know why, because we have the big cantilevers, and you discuss how you're after affordability, but I think that form dooms you to like a $450 a square foot structure is what my quick calculation was. And so out here in the builder world, we're just constantly grappling with these crazy costs and how do we really get value out of it. And for me, I'm an engineer, I'm not an architect, but I don't think this form fits with the context. That you were really careful to talk about the context, but then when I saw the form, it was a little jarring for my sensitivities. So I should shut up and let the architects talk about that. But that was just an impression that I had.
No, I totally think that's fair. I don't know if you want to go back to any of the context stuff, but if you're looking in the area, most of the buildings were built 1900s, maybe even earlier. There's a few new buildings on there. So we were kind of trying to make a mesh of the both, taking a lot of the ideas from Mission Hill, thirds, some of these materials, and kind of trying to find a middle ground where we're having a progressive building, but it's also still respectful to the context of the space.
Yeah, I think it's important not to repeat the context, but respond to the context. And so I do think there is some success in trying to repeat the rule of thirds, but I do think the massing maybe could have handled a little bit more sensitive. But the bigger point would be going back to, I think it's really important when you make these big moves architecturally like that, that you also understand the cost impacts, the energy impacts, et cetera. So that's where I think the importance of the modeling and fully understanding it. So you spend that money wisely, probably. Sorry to rant a little bit there, but then going back to the envelope question that Jean brought up too, I had the same observation. You know, the double wall I think is a really great solution. I think it's affordable. I think you've proven that. But I questioned that you used foam in two walls instead of some sort of vapor open, breathable, more environmentally friendly insulation filling that whole cavity. So and it sounds like you had an energy model or a envelope consultant involved. So I'm just curious what the input was there and the thought process there and so forth was. But
so working with a group of mainly two people, starting this project fairly later on in the year, early this year, it was definitely hard to get every aspect. So we did have those 4 consultants. I would say she helped us to the best of her ability of, you know, what she typically does and what she would use and what she recommended. So I think we could have done a better job of questioning her and kind of asking for a little more information about why she chose to have us use the air gap in the space. But yeah, I think that's kind of how we kind of took about this.
I think just quickly too, the 6-inch roof thickness was another thing that really caught my attention for your climate zone, being way underdone too for reference, but yeah.
I love the weather graphs, by the way. They were great, so colorful.
Yeah,
love them.
Yeah.
If there's no more questions, we still have a few minutes. But yeah, go ahead.
I would need 3 mics. I was just picking this up, just caught my eye as you were cycling through that you mentioned natural gas. Are you using natural gas for heating?
We were using a heat pump.
Okay.
Yes.
Hot water. Okay. Okay. That's it. I was just questioning like the heating that you were using and trying to get gas out of the system.
No, yeah.
Okay. Cool. Because I know Boston, I mean, they have oil boilers and it's old technology. So, yeah.
And we actually both live in Mission Hill. So this is a site that's very close to us.
Yeah.
So we were really able to get a perspective of what the residents need in this area and what's something that's helpful. So like we didn't want to take away from the pedestrians because this is a very walkable area. We all walk to class. We all walk to class for 8 a.m. So having that cut through, I know would be very helpful, especially for him because he actually lives right across the street from the site. So it's something that we really wanted to highlight in our project was how we connected with the residents. And then I think it helped every residents ourselves.
Yeah. I used to live right down on Huntington. I went to the museum school for a couple of years, so I know that area.
Yeah, this is actually the SMFA. Like the site is right next to the SMFA.
Oh, they own this site. Okay. Yeah. Interesting. Cool. Nice.
All right. Thank you, Wentworth.
Thank you guys so
That
much.
was
Thank you so much.
Next up, we have the University of California, Los Angeles. But before that, we have a short break. We'll have them present at 2:40 p.m. Can go ahead and start.
Okay. Hi, we're Bruin Builders, representing UCLA with our attached housing project, Module Nature. I am Max, the team lead, and throughout the presentation, speakers of the architecture team are gathered.
Max, we don't really hear you right now.
Again? Is
Can you
anything?
try?
Oh, again? Should I do it again?
Could we get a confirmation if Max?
Yeah. Yeah, this
I
is.
can hear Max. I can hear
You
Max
can,
as well.
okay, you can continue. We'll make sure we adjust the time when it comes to the end. So just continue your presentation.
Okay. And this will be the order of contents we will discuss for the presentation. Gavin.
Thanks, Max. So when we were starting this project and picking a site, we were hoping to increase the urban density, but we're also looking to build on a site that didn't have a building on it to lower impacts. So we chose to respond to a request for proposals from the city of Los Angeles that was asking for the redevelopment of 2 large parking lots that were located in the historically Black neighborhood of Lemur Park. And here you can see kind of some historic landmarks in the present day situation. Next. Here's a closer view of that neighborhood with the lots, the parcels we selected highlighted in blue here. We chose a smaller area just due to the area requirements of the attached housing competition. But you can see some street views of the streetscape, the kind of downtown shops, the historic Vision Theater, and Park and Marketplace to the south. Next. The direction. So the zoning is C2 commercial, which allows for our R4 uses by right. And there's also a lot of great amenities located nearby in the neighborhood, so it's very walkable. Next. One key consideration was the light rail construction by LA Metro that's linking Los Angeles Airport to the greater metro system. So this is really great for transit in the community, but it's also spurred a lot of development, which is raising prices. So our project is hoping to respond to this by densifying the downtown, adding more units, but keeping those affordable through our construction techniques. And we're also hoping to tie in with other community projects. Next. We performed market analysis, and overall the demographics are 60% African American and also some Hispanic. There's just in general a disparity between the kind of high median household, the lower median household income, and the higher rent prices for 1-bedroom units. So we're looking to target low to medium income residents, and with rents of approximately $1,000 a month. So we're estimating to achieve this with a 3-year construction timeline and costs around $300 a square foot. Next. Overall, the climate zone here in Southern California is very mild and favorable, but we do expect that temperatures will be increasing, especially in the summer, and more extreme events such as heat waves. Next. As I mentioned before, the biggest consideration is the affordability. We're hoping to keep these residents in the community. We're also hoping to connect members of the building to each other through shared spaces, promote outdoor living with mild climate, provide varied apartment types for different family and living situations, provide passive techniques and energy efficiency, and also integrate the building with the general neighborhood and downtown park context. Next.
For our technical goals, we want to aim for a net zero energy building. We want to be able to capture and recycle our water. We want to electrify our appliances. We want to take an integrated systems approach to our building design, have a tight building envelope, and lastly, have a low embodied environmental impact. Next.
So the design approach towards this project is to create a space where communal spaces like podiums and platforms as shown in the rendering can connect with residents in order to enhance social relations. Next. So a number of voids are created within the buildings in order to create skylights and openings to allow vertical ventilations and allowing natural sunlight to go through. Next. So we also collaborated with Plan Free Path about the details of modular designs as a base to centralize utility systems within the modules and create different spatial configurations through shifting the modules within the layout and hence creating various types of housing units for different needs. Next.
The interior units will utilize wood framing, while the exterior platform will be a concrete steel deck with an elevated decking supported with adjustable pedestals. Similar structural design procedures are required for both traditional light frame construction and modular construction. The latter was selected for this project because the construction time and the overall cost of the project will be significantly reduced, as each type of the module can be prefabricated in the factory, shipped to the site, and then stacked and assembled within days. Next. We considered several passive strategies when designing the building, including sun shading, thermal mass, and night flushing with tiled floors and natural ventilation. We used a large wrapping roof canopy and exterior patios to set back the units to avoid east-west sun. The orientation is ideal for naturally cross-ventilating with prevailing coastal winds. Next.
One way we elevated occupant experience is through xeriscaping. This saves water by using native Southern Californian plant species that require less maintenance. It also brings out biophilic patterns that connect residents through nature. Next.
And we promote occupant experience by emphasizing outdoor living in the mild Southern California climate. The shared patios encourage interactions between residents through allowing for events of various scales, or the roof wraps can provide a sense of enclosure and privacy to our residents. We bring additional light to the building core via light wells that also function as vertical gardens. In the next slides are typical details of a building frame in an envelope. For clarity, the ceiling framing of the typical double floor system for modular constructions is not shown. The drawings describe the structural system of our roof, wall, floor, and crawl space with the insulations and joists shown. The framing is designed to support a 3-story building, and the envelopes is designed to meet the insulation target for Climate Zone 3B. One notable material selection is cellulose insulation. Cellulose has a high insulation capability and will be recycled from newspapers. These meet our technical goals of having a tight building envelope and a low embodied environmental impact. Sterling.
The HVAC loads shown to the left were performed using a manual J calculator, namely CoolCalc. And to meet these demands, we chose to implement a modular ground source heat pump system that's comprised of two 45 kilowatt heat pumps in series that are connected to a vertical borehole network to facilitate that heat exchange during the heating or cooling processes. Such a system's performance is not affected by extreme temperature variability, and the piping is known to last up to 100 years, making the ground source heat pump a design that's built for longevity. Based on our calculations for yearly water consumption, we designed for 2 hydroloop units to operate in a cascading system by recycling the gray water from showers in the washing machine to flush our toilets. We determined that we'd be saving close to 580 gallons of potable water per year. What's unique about the hydroloop system is that it doesn't utilize filters or membranes in the recycling process, so it does not require frequent replacement or cleaning. To the right, you can see a rendering of our solar panels on the roof of the building. According to our available area and efficiency metrics shown, we calculated a total energy production of close to 70,000 kilowatt hours per year. This makes our building resilient toward grid outages and can be used to service occupants during peak demand hours. Rather than placing these panels in series for a single inverter to convert the power, from DC to AC, we want to utilize microinverters located in each module to allow that system to perform even if there's an issue with a single panel. And overall, these systems discuss work to reduce the building's overall energy and water consumption by localizing processes that are conventionally performed off-site.
Occupants are able to change the dimness and the temperature of their lighting to suit their own needs. We opted to use LEDs as they are very energy efficient and have a long average lifespan. In addition, our decision to go with Energy Star appliances and EPA WaterSense fixtures allows us to save water and electrify cooking and appliances. Next slide. And for a site EUI, we calculated 15 kilobtu per feet squared per year without renewables, and this drops down to 3 with renewables. Despite the site EUI not reaching 0, we are pleased that we were able to design such a high-performing building that is for multifamily attached dwelling that caters to a high occupant density on the site. Next.
All right, you're at time. If you want to conclude in 1 or 2 sentences, we'll move on to the Q&A.
Okay, yeah. This final slide shows that we conducted a life cycle assessment, a building circularity analysis, and yeah, that was basically the last slide. Thank you for your time, and we look forward to hearing your feedback.
Thanks, UCLA. We'll move on to the Q&A. Parag, would you like to go first?
Yeah, so when I think of LA, the major concerns are for me, and I don't live in LA, so this is very much secondhand, is the sun, the heat, right, and air quality. So I really appreciated the fact that your proposal does, of course, acknowledge both those contexts and urban sprawl, and as like full marks for considering ventilation and filtration of air. I really like that part. My question is, I was missing a discussion of resiliency, because LA is hot, but it's gonna get hotter. It's gonna get worse, and climate change is going to disproportionately impact hotter places. So can you speak a little bit to what your response is to the problems of resiliency for this region?
Yeah, I can go ahead and comment a little bit on that. So firstly, you know, with the process of electrification, with processes is possible on site, whether that's our
Would you like
HVAC.
Sorry, Sterling, could you go back and repeat that? You cut out for quite a bit there.
Sorry, yeah, I might have cut out. Can you hear me now?
Yeah.
Okay, great. So yeah, what I was going to say is that in terms of resiliency against heat waves that might cause blackouts or grid outages, specifically, such a design like having solar panels on our rooftops would allow electricity to be diverted to our residents if there was any sort of issues with the grid. Kind of thinking about this, we didn't get a chance to explore many battery storage options that could work with solar panels to cater to this need. Additionally, I would say that having a ground source heat pump where we are trying to utilize the renewable sort of supply of the earth as either a hot or cold source for this process, just overall brings this theme of bringing these processes on the site rather than sourcing them from somewhere else. That's probably my best comment towards the resilient aspect of our building.
So I loved your guys' presentation. It's very professional, and this group image is great, probably the best one so far. I was gonna kind of build on that. Do you have earthquake considerations? I think I saw it probably in your materials, but don't remember you talking about it here. And then fire as well, as there are more and more fires in California. I assume some of your filtration systems will deal with that, but if you wanted to respond to those two threats specifically.
I can respond to this. Yeah, we're aware that this building is located in Los Angeles, which is like a very high seismicity zone, and we do consider earthquake. And the structural system of the entire building will be designed for the level of earthquake that the zone is going to meet. So for example, we'll be using shear walls, like we'll attach plywood to the wood framing, which will act as a shear wall to resist lateral loading. And all the forces will be transferred to the foundation. We have a dual foundation. One is like a slab on grade system. The other is a crossface. The crossface was introduced to allow access to the mechanical units, which are located to right underneath the core modules. So yeah, but we did consider the seismic aspect of it. That's why we have a structural separation between the main structure and the exterior patio. There would be a seismic separation between the two systems, but the waterproofing envelope would also. So in the other reason why we separated the interior and the exterior is like to allow the waterproofing envelope to be enclosed within the units, so water doesn't go into the structure, and the exterior patio would have its own drainage system. As a fire, we'll be using concrete cement tiles on the outside, and the interior would be 2 layers of 5 5/8 thick gypsum board, and the wall envelope. So the wall, sorry, I think I lost my term there, but the entire wall and floor envelope, they are designed for the 2-hour or even more fire rating as required by the code in the LA region.
And one, I'll just make a kind of final comment. I really like that you were also thinking about the social experience of the residents, making sure that there's places for them to come together, especially in a pandemic. We've learned how important that is. And I don't think it was in any of these images. You had one where there was kind of a external fencing type, rain screen type thing. Yeah, would caution about that becoming like a barrier between the residents. It could be useful for safety, but it also, in one of the renderings, it just kind of looked like it was cutting off your residents from the neighborhood. But that's just a comment.
So I can clarify that. It's actually not included in our presentation, but that's a street facing screen just to provide privacy, since some of those patios are directly on the street. So we chose a screen to provide the residents some privacy off of that while still letting light and air circulation.
Oh, wait, can you guys hear Gavin earlier?
Yes.
Okay.
So I like this building. I think it's a really cool design, and
nice mix of material.
And I'm the engineer, so I'm not supposed to know about aesthetics, but I like this building. I think it's a beautiful building. Had a couple of questions on your wall section. You referred to a PVC weather resistant barrier. I really like vapor open on wall sections, and PVC gives you not vapor open. And so I'm really concerned about that. Is there a particular reason that you went with that?
I guess I can answer that. I'm not exactly quite sure what you were referring to, but I think most of the decisions we made were just informed on some of the research we were able to conduct, but definitely we are open to looking at better options. Yeah.
Okay. And then on your market analysis, it looked like you were at least in one part of your narrative, you were targeting 40% of total income, and then elsewhere in the narrative, I think you referred to 30% of area median income. Can you clarify what income level are you targeting for this building?
Yeah, I can clarify that. Sorry, it was unclear. We're targeting low to medium income, but we want the rents to be no more than 30% of their total income. So
you were cutting out there a little. I think did you say a 30% debt to income ratio?
Yeah, so income to total, rent to total income ratio.
Did you guys hear that?
No.
I'm having
Gavin, you sound like you're in a fishbowl.
Yeah, I'm having a hard time hearing your, I think you might have a microphone problem. Can you guys hear it and interpret for me? I don't know what else to suggest.
Sorry, is this any better?
Can you say slower?
Okay, it's a 30% rent to total income ratio.
Okay, all right. I think your building is too expensive to get to that, and I had some suggestions on it. I think a ground source heat pump makes no sense in this climate. I think you've got a very mild climate to deal with, and that's a very expensive solution. And I've been saying it all day, and maybe I'm wrong. Somebody needs to tell me why I'm wrong, but I think you've got a very benign climate there that could have probably gone with a very economical system. I don't think you need hot water heat in this kind of a climate. But again, I really love the building, and I think you did a nice job.
I can address the ground source heat pump. I actually do agree with you. We don't have very extreme temperature variability, which would take away from the efficiency of conventional air-to-air heat pump. What I would say is that we had dedicated a lot of time towards designing such a system, and had gotten to a point where we were discussing it amongst ourselves whether to pivot and change towards another solution for this. But we ultimately decided that because we had kind of started with a lot of our research and devotion towards a ground source heat pump, just in the mind of trying to implement some of these more innovative solutions, I would say that we decided to just carry out with it. But I definitely agree that there are more reasonable and ethical solutions, I suppose, towards meeting like the HVAC needs. But thank you for that.
Nice job, guys. I too think the architecture is very, very elegant. And I really liked how whenever you made a form move, it seemed to support what you were trying to do from a sustainability standpoint. It had some, not only a beauty aspect to it, but it had a functional aspect to it. So appreciated that a lot. I also appreciated the fact that you're thinking about the neighborhood and not gentrifying the neighborhood by using a parking lot to build on in lieu of other options. I think that's very admirable. Like Gene, I was also taken back by the mention somewhere in the narrative about the PVC membrane for air tightness, and also feel that we should be moving towards vapor open, and also PVC as a red list material. So it's something we're trying to steer away from. But more broadly, I'm not quite satisfied about maybe your answer on what your overall air tightness strategy was for the project. I think air tightness is very important, not only for efficiency, but also for resiliency and indoor air quality, et cetera. So we'd just be interested in hearing a little more about that if you're able. Yeah.
Kaiji, do you want to speak about that? Because I honestly can't say much about that.
And I can shift to a different question if that's a real stumper too. So.
Okay, then maybe shift to another question then.
So maybe if you could also speak to maybe the maintenance costs. I did not see mention of that. Maybe I missed it, but if you could speak to that, that would be helpful also.
Do you are you referring to just the overall maintenance of the building, or just of the equipment in general?
Overall maintenance. One of the topics for the contest is market analysis, and it includes operational and maintenance cost estimates. And so I didn't see that covered. So I was curious if you had any more thoughts about that. I did see a little bit on life cycle. But.
Yeah, so we unfortunately didn't get to dive too deeply into operational maintenance costs. What I would say is that just we've designed for systems to not need to be replaced frequently, and we've designed for them to essentially be able to perform in their. I'm trying to come up with the best way to answer this. Yeah, go ahead, Gavin.
A few things. Yeah, it's true that we didn't include it in our financial analysis, but we did try to select materials that were low maintenance, like the fiber cement panels, the Hydroloop system. Yeah.
Okay. Thank you.
All right, thank you, UCLA. That was a good job. Can you give them a round of applause? Next up, we have Ferris State University. They'll be presenting at 3:10.
Thank you.
Thank you very much.
Thank you.
All right, you guys can start presenting.
Currently, only 24% of students attending Ferris State University live on campus, while 76% live off campus. We are restored to sustain from Ferris State University, located in Big Rapids, Michigan. With our project, the Revitalized West Campus Village, we would like to attract more students to on-campus housing with a more affordable option.
I'm Alex Garber.
I'm Adriana George. I'm McKenna Parks. And I'm Kylie Wyman. Throughout our project, we have worked closely with local industry partners. The mission of the Revitalized West Campus Village is to provide affordable housing for students and to influence additional students to attend Ferris State University. With the hopes to improve our own university, we chose to retrofit an existing apartment complex located on campus. Currently, these apartments house students and their families. Narrowing our focus, we chose an apartment that includes 6 two-bedroom units and 1 3-bedroom unit. Essentially, our goal is to implement the design throughout the entire complex.
Big Rapids experiences cold winters and warm humid summers. We have an average high of 82 in July and a low of 14 in January.
Our design goals were to retrofit an existing building as it is more cost efficient. 80% of homes that will be occupied in 2050 are already built. Achieving affordable housing was necessary to help reduce the amount of financial stress on college students. Our low-cost on-campus housing will increase the attendance at Ferris State University. Our design promotes a healthier lifestyle. Living on campus will provide walking to class, make it practical. The walk time to class is less than 10 minutes. A sense of community is achieved with the proposed courtyard. This outdoor gathering space is shared with the adjacent units to promote interaction. As mentioned, one of our goals is to provide affordable housing by reducing utility costs. Our research shows that high energy costs can be a burden for students who are often occupied or stressed from school, work, and extracurriculars. This chart shows that a concerning amount of students cannot afford to pay their full utilities over the past few years. Throughout our project, we focus on the inside unit A and the outside unit C. Essentially, we improved the exterior thermal resistance, finished the basement, integrated a 4 seasons patio, and upgraded the courtyard. We kept the existing cabinetry, outlet, and appliance location the same while updating the appliances to be more efficient. In addition to finishing the basement, the utility closet was added. The solar panels are located on the east and west slopes. The exterior of the building was updated to attract students to living at West Campus. 3 inches of rigid insulation was added to the above grade envelope. Roofing materials, siding, windows, and doors were replaced. The basement walls were finished with 3 inches of rigid insulation, 2x4 wood walls over top. The floor is a floating floor system with 5 inches of rigid insulation. We kept the footprint of the existing back patio slabs and integrated an enclosed 4 seasons patio with CMU wall located on the north side to act as thermal mats. On the entry side of the building, we brought the walls and siding of the closets down to ground level to reduce the amount of heat loss and debris to be trapped underneath. By utilizing a thermal imaging camera and heat flow devices in our current apartment, we were able to distinguish where improvement was needed. To improve thermal resistance of the existing building, we increased the amount of insulation and added more efficient materials. We were able to increase the exterior wall value to an R30. Furthermore, the slab was increased to an R23 and the roof is now an R53. Finishing the basement increased the foundation to an R26. Finally, the windows were exchanged for efficiency and are now a U.25. Primary housing market in Big Rapids is college students who are looking to rent an apartment or house. As seen on the charts, room and board costs are exponentially rising and they're rising even higher than the rate of inflation. The option of applying for an education grant that supports sustainable projects is available for the university to help cover upfront costs, which we have figured to be about $58.60 per square foot.
West Campus Village is renovated to withstand Michigan winters and stay cool in summers. The building integrates the 4 building science control layers: thermal, air, moisture, and vapor. The existing apartment was restored to withstand and recover from natural and human caused risk. This was done with fiber cement siding, a new metal roof, and durable vinyl flooring.
Through a detailed life cycle analysis, we were able to analyze the environmental impact of our building and materials. Our analysis showed that our building has a global warming potential of 197,000 kilograms of CO2.
meaning this amount of carbon dioxide would be emitted over the course of our building's life. Due to the use of concrete, the global warming potential was the highest in the production and operational stages. By choosing other recyclable and local materials, we were able to reduce the building's impact during the transportation and end-of-life stages.
We work towards a seamless overlap of architecture, engineering, comfort, and environmental quality of West Campus Village. Our project emphasizes the integrated performance of the exterior envelope, HVAC, lighting, and passive systems to achieve desirable results. Solar collection and tight envelope daylighting and a cold climate air source heat pump are implemented to create efficient attached housing.
With much more focus on students who sometimes experience less than ideal living conditions, providing high environmental quality was essential. Well-lit interior spaces with high air quality and new efficient appliances, such as the newly finished basement, provide occupants with opportunities for gathering and personal activities. New exterior renovations will make the outdoors convenient and accessible as well. The Four Seasons patio and entrance courtyard are the strongest examples of this.
Given that the building will support multiple students and families, a large amount of physical control will be used between units. Sensors will be utilized throughout the space to ensure the building is operating efficiently. The sensors will be used to automatically adjust the comfort and environmental quality throughout the space. By controlling temperature, humidity, and movement of the air to keep it fresh, using dehumidifiers and fans.
To keep the cost of housing low for students, the revitalized West Campus Village will entirely omit a monthly electricity bill. Ferris index ratings were calculated for the existing and post-reno apartments. The ratings were improved with the renovations along with the implementation of on-site generated PV. 365-watt PV panels will now be used in order to achieve net zero status. A 3-bedroom outside unit containing 3 exterior walls and 1 adjoining wall generated a current HERS index of 75. The proposed HERS index is 42 without PV and -1 with PV. A 2-bedroom unit that features adjoining walls to the north and south has a current HERS index rating of 81. After renovation, the HERS index is 47 without PV and 0 with PV. We are so thankful for the opportunity to compete in the Solar Decathlon. Throughout our project, we have gained valuable information that we will apply in our future post-graduation. Ultimately, the revitalized West Campus Village would improve our university while providing students with a net zero living experience that can be learned from, thus influencing their future participation in the Net Zero World Initiative. Thank you.
That was a great job, Ferris State. Let's start with the question and answers. Do we want to start with Melanie?
Hi. It's always challenging when you guys are doing retrofits, but also very real world situations. So I applaud you guys for doing that. And I was particularly impressed with your reclamation of the basements, both as livable space for the occupants and just adding insulation and then, you know, keeping the temperatures down there moderate. I think you might have mentioned this in some of the other materials. Did you get to go into one of the units and look at it and talk to any of the residents? I saw that you did the thermal imaging too. That's great.
Yes. Yeah, we did go into the apartments and talk to one of the students, but I had also lived in the apartments, so
Okay.
I also had a little bit of insight on it.
Okay.
Yeah.
Great.
So you're saying you were your own lab rat. That's a pretty good background. I really think you guys did a very solid job of building science. And as I've said multiple times, I'm the engineer on the group. I think maybe there was some missed opportunity for color and maybe some additional materials or something to just jazz it up a little bit more. But that's a minor aesthetic kind of a comment. I also loved how you kind of reclaimed lost space out of the basement for the benefit of students. And I would imagine that having a place to get a loan and do something is pretty important. So having that own little floor to, I guess that's a long way of saying, I think your occupant sensitivity was really strong. I do think there's some insulation overkill going on here. I think you were using the same thickness of foam in that slab at the basement as you were in walls. And, you know, if you think about the delta between the temperature of the soil down 8 feet below and where you are, you probably didn't have to do that. And I can't honestly remember what kind of foam you're using, but thinner would be better for some kinds of foam. So I just thought, again, very solid envelope, but probably you could optimize it a little bit from where you've been. You mentioned a double wall for the party wall, adding a double wall for the party wall, but I didn't see any details on that. Did I just miss it? Are they in the report somewhere?
The existing like building already has like the double wall. We didn't do anything to like the
Okay.
spaces, so we didn't actually.
Okay. I misunderstood that part.
Hello. I think it's very admirable to take on existing building stock and improvement. It's of course much more sustainable to do that than to build new. And I think you did some really nice things and had some really nice sort of what seemed to be what would be real world success, the HERS rating improvements, et cetera. I think the things you did with the architecture in terms of adding the green spaces, the community areas, the solar rooms, what I mean by the green spaces, I think are all very nice things. But I also think that when you go to the extent of reskinning a building and I think probably replacing the fenestration as well, it's a really great opportunity to do something expressive with the architecture too. So, you know, it would have encouraged a little more exploration in that regard. The question I have for you then relates to maybe energy modeling and opportunities there. And it seems to imply from the narration, and maybe I misunderstood it, but you were kind of following code to meet your systems. And not only code, but code that was 2015, so a little bit older code. So I'm curious to know if you did any modeling on top of what it took to meet code to analyze performance relative to not only the efficiency of the units, but also maybe relative to the size of the solar array. So, you know, possibly being able to reduce the array and still achieve very good performance, et cetera. So hoping maybe you can speak to that a little bit. So, yeah.
Well, I think we could have gone a step further and done some sort of energy modeling.
Yeah, as for the solar panels, we had help from Michigan Solar Solutions kind of discussing what is the best option and how many panels, and they kind of gave us a number for that. So we didn't really explore too much past that, what we were given, but we definitely could have.
And we do have extra solar panels than what is needed, just in case of certain ones, we have to use more energy.
Thank you.
So kind of know from personal experience how depressing these places are to live in. That was my first year of university, was in almost the same kind of housing in Lafayette, Indiana, and it was just depressing to walk to class. And it's just, yeah, built in the 50s as temporary housing, and 2010 it's still there. Right? So yeah, full marks for trying to improve that living experience. So you mentioned one of my, so first of all, yeah, full marks for using thermal imaging cameras. Great touch there.
Yeah.
And you mentioned one of my favorite words is sensors. Can you talk a little bit more about what is your strategy for using sensors, and like how does that change the occupant experience?
So our goal was the lights come on when you get there, shut off and make this couch. It's not priority to shut the lights off or electric bill.
Yep.
And they'll control the temperature in spaces that they're using more, so they don't have to go out of their way and do it their own, because, you know, do more than we have to most of the time. So it's just make it easier for them to keep.
Especially during those breaks, and spring break when they leave, just making sure the units are running efficiently.
Yeah. I mean, I did a project on that in my undergrad for Purdue, and it was a staggering amount of waste we could save from these occupancy sensors. But the problem was electricity was so cheap, didn't justify the cost of installing. So is that not the case in Michigan anymore? Is the electricity expensive enough to actually justify? Because you did talk about utility costs, right? Has that changed somehow in the Midwest, that suddenly energy is more expensive?
I don't think any of us have research that.
And getting more so. Okay. Yeah, I was gonna say.
I can add to that. So we've been asking before about maintenance. I don't know if you guys spoke to, so who actually owns the spaces, and is there, or would there be external company that would come in and help maintain, like when an occupancy sensor goes down, or would the burden be more on the students to kind of understand the systems and keep them running?
So the apartments are owned by Ferris State University.
Hmm.
So Ferris State Housing and Residence like kind of deals with any problems, and then they can direct occupancy sensor problems to the facility management department.
Okay.
Also throughout the project, we were in contact with them.
Great.
Any questions that we have, they are helpful.
Great.
So I really like the winter garden concept. I think that's what you call the Four Seasons patio, right? But I was missing a little bit the discussion of durability and resilience, right? So can you just talk to what are the primary challenges for resilience in Michigan? I'm going to stay in character and say what happens when the grid goes down, because my boss lives in Michigan, and I kid you not, the number of times we're on a call and it's like, sorry guys, my power went out.
I feel like that is an issue that is still being solved in Big Rapids because it's such a high population of students that we're all using like Wi-Fi, for instance, and it goes out multiple times.
And then you have a riot because the Wi-Fi went down. Yeah.
So many people using it that it takes forever to come back. But we didn't explore any options of what specifically this was.
But what are the challenges actually? Don't need the solution necessarily, but what are the challenges for Michigan now?
Cross law is our biggest challenge, and then to be student housing, how hard they are in here compared to other people that are their biggest challenge, and after it gets pulled up to them for years to come.
I made a note, and I'm trying to find it in your narrative, but there was an interesting heat flow study that you had done. If that was a pet project of any one of you, that you could maybe elaborate on that a little bit. And I'm trying to find it still, but.
So yeah, we went to an existing unit and we put heat sensors, heat flow devices in the living room of the space, which would be the eastern wall. And then we also put one in the basement space on the same wall. And then we left them for a week, and then we kind of came back, got them, and the basement space definitely fluctuated a lot. We saw, and interestingly enough, the living space also like had fluctuation with its heat. But further, we didn't further like explore too much of the information that we received, but we did use those graphs, the information that we got, and thinking about installation and materials.
All right, thank you. That was a great presentation and a Q&A round. Thanks once again. The day, so we'll have Ball State University presenting at 3:40.
So not all of them in the cycle, but this one is. It's got a stiff back laptop.
All right, you can go ahead and start presenting.
My name is Tyler Renchin, and I'm here with Charlie Davis, Zealand Stutz, and Dylan Reddy. Together, we are Studio Zero and Ball State's attached housing group. This is Project Zero. Project Zero's site is located in the Inglewood neighborhood of Indianapolis's Near East Side. The Near East Side is home to roughly 30,000 residents and has recently become a focal point for new development. An example of this development can be seen through the reclassification of the Inglewood community as a transit-oriented development. The TOD is centered around the new rapid transit bus route that is just 1 block south of Project Zero's site, connecting it directly into the heart of the Indianapolis.
Project Zero's site functions as a prime corner lot with frontage on New York Street, a busy road with mixed-use zoning. The other 3 sides enter into more intimate residential housing with alley access along the east face.
The annual median family income of Indianapolis rests at $47,000. And with the Inglewood communities being less than half of that, this creates a deep need for affordable design. Working with Inglewood CDC, a community development partner, and utilizing their community goals seen here, Project Zero strives to increase livability, opportunity, vitality, and education, not only for its occupants, but for the community members as well. Also, to compete in the affordable housing market of Inglewood, Studio Zero aimed to keep construction costs below that of the market average, which rests at $200 per square foot. Project Zero also follows a rent-to-own pathway, which is preferred by Inglewood CDC, and it gives the occupants some incentive to grow in place.
The majority of the built context in the surrounding neighborhood is run down or abandoned single-family homes. These homes sit in contrast to new development within the TOD and along Washington Street.
While studying the neighborhood context, it was found that minimal property setbacks has created consistent spatial inefficiencies. These spatial inefficiencies then culminate into thousands of square feet of non-usable space. In contrast to this, the traditional row housing typology has a different type of spatial inefficiency, with units sharing 2 party walls and only short facades with exterior access and little to no green space. What if these spatial inefficiencies were transformed to maximize the space for community and exterior access?
Project Zero responds to this question by breaking from tradition, splitting units into pods, which allow for 3 facades to gain exterior access. The spaces left from the split are then turned into community courtyards. These courtyards and pods are reunified behind a recycled aluminum rain screen or facade. The facade blurs the line between the built units and courtyards while providing a layer of privacy and safety.
The design culminates the set of units that fit into the Inglewood fabric while offering a fresh architectural statement. Project Zero includes 6 affordable housing units ranging from a 2-story 2-bedroom to a 4 2-story 3-bedroom, along with 1 3-story 4-bedroom unit. All units have 88 accessible first floors that maximize visibility. To respond with the current market trends in the Inglewood community, Project Zero has created a co-working space allowing for community members to have a safe environment within walking and biking distance. Within the unit, circulation was placed along the interior party walls to maximize the sunlight in the living space. The first floor design also promotes visitability with a full bedroom, 8A shower, and seamless grade-to-grade access. The open floor plans allow for occupant autonomy, which is necessary for the future occupants and their families to turn the units from a house to a home.
Between pods are shared courtyards. This creates an element of co-living and allows for a space for neighbors to come together. What if these spaces became an extension of the occupants themselves, giving them the power to build a unique shared experience? These spaces could transform into a place where kids can safely play while grandma watches. A space where families can come together after 2 long years apart for a barbecue. Or perhaps these spaces may want to come alive at night. This is all possible when occupant autonomy is allowed to flourish.
Looking into the performance of Project Zero, an integrated design method can be seen through the use of passive and active systems, allowing for heightened comfort and efficiency. One example of this is a response to local flash floods and wastewater management overflow. Project Zero utilizes multiple green roof patio spaces connected to on-site bioswales and dry wells, removing the need to relocate water off-site. This also increases the durability and resilience of the roof membrane.
Project Zero can also use the passive stack effect for around 600 hours of the year. This increases, obviously, passive ventilation.
Consolidating utility runs saves on both material and labor. Each unit is equipped with an air-to-air heat pump, as well as an ERV for ventilation. Materials will be proven low VOC through the acquisition of EPDs, and units will also be equipped with circuit level monitoring, UV air scrubbers, and environmental zone control.
Each unit is equipped with standalone PV and Tesla battery walls, producing and storing power on site. Power storage has become paramount in Indiana, where net metering has recently been eliminated by law. This solution saves occupants an average of $2,880 a year. Studio Zero had an energy goal at the beginning of 25 EUI. After active system design and PV integration, the average EUI ended up being -6.
So designing a net positive building requires careful consideration to maximize both efficiency and durability. When we look at the exterior envelope, Project Zero aims to reduce material loads, thermal bridging, and maximize durability and resilience while hitting core FIAS requirements. This is all accomplished using bare naked T-studs, which maximize continuity of insulation, and Shushugi bond plywood siding to increase durability. The slab and foundation follow similar principles through the implementation of a frost-protected shallow foundation and a concrete-free slab. Located beneath the slab, you can also find an active radon mitigation system.
Attached to the east and west face are aluminum facades, which provide both functionality and character. The recycled aluminum facades play with your perception of depth by providing a sense of translucency to the semi-private courtyards. Common passerby is meant to naturally engage with this dynamic facade during a walk down the street.
The embodied energy and the environmental impact are minimized throughout the design of the project by reducing material use, using recycled materials, and locally sourcing those materials within a 45-mile radius.
Finally, the co-work space not only supports the occupants of Project Zero, but the community members as well. This draws in the surrounding community, allowing access to an educational, multi-use co-working space for all ages. This space fills the need created during the pandemic, where professionals have been noticed reducing the number of hours logged in traditional office space. To recap, Project Zero is a new take on traditional attached housing, allowing users to transform what would typically be unused spatial inefficiencies into places where people want to occupy. Thank you.
Thank you, Boss Dave. That was wonderful. Let's move on to the question and answers. Jean, would you like to start us off?
Hey, guys. Nice presentation. I think your building is very interesting.
Thank you.
I am stunned at the $23,000 income you're trying to hit at a $500 mortgage payment, and very skeptical that this building will get there, to be really honest with you. I love your aluminum screen. I think you made a statement in the narrative that you could save 95% of the cost because it was recycled aluminum. I think most aluminum is recycled these days, so I'm not buying that part. But I do think it's a beautiful building. And I feel like there's some overkill on your sections that would help you hit your affordability target. And I don't know if you can pull up your slab section, but I think I saw 3 layers of foam, and let me see what let's see, R30 sub slab insulation with multiple layers of crushed stone below gravel, below 3 layers of rigid foam. I just don't think you have to do that on sub slab insulation. And again, you know, if you were at one of the previous ones, you're looking at what's the temperature differential between where you're trying to be at 70 degrees and where you are on that slab on the ground. And I just don't think you have to be that complicated in order to solve the problem, which would really help your affordability. I do think the shared spaces are really good, and I think that's a real sensitivity to the occupant. And the model is terrific. Good job.
Yeah, hi guys. Beautiful presentation. very well orchestrated and planned. Beautiful building too. I like the architecture a lot. I suspect your neighbors might be not quite as fond of it, but I think it's a very handsome building. I really like the idea of sort of taking that typical single family neighborhood pattern and capturing that, as you called, wasted space between the sort of no man's zones that are there to meet zoning requirements and building code requirements and so forth, and making better use of that. Very, very nice that you did that. Moving away from that, you mentioned that somewhere in the narrative that you could achieve passive house certification, or implied something that the passive house, our values were there or something. So I'm wondering if you could just speak a little bit more to that.
Yeah, so that kind of goes back to the question that Gene was having about our slab. And that's basically, we could have probably gone a little deeper and done some sort of, calculation on sort of like the soil and how much heat loss we're getting through that. But yeah, we really did orchestrate our wall section, roof section, and slab, and foundation sections with passive house certification level insulation, in mind.
Air tightness and ventilation and windows as well.
Correct.
Yeah.
Use their website to try and find products, or at least comparable products.
Mm-hmm.
And this was the core bias prescriptive.
Gotcha. Yeah, thank you.
Yeah, so yeah, I love the concept of shared spaces. I think that the place where I lived about a year ago, until about a year ago, had a shared space, and we used it. People do genuinely come out when there's a protected space. It's very important. And as you said, you can, the sort of Jane Jacobs style of being able to see your kids play, and there's nothing better than that. So I love that concept. And I also noted down here that I think you probably have the best treatment of ventilation, which full marks for that. I am going to ask a little bit though to try and tease out the concept of passive house, right? So passive house, it's all about, space station, extreme insulation and air tightness and everything. But Indiana does get hot, right? Hot and muggy, right? And those giant cockroaches and everything, right? So, so there's no shading, right? There's no, so, the more airtight you make it, the harder it is to ventilate in indoor gains and stuff. So apart from active systems, you don't really have passive systems. And what happens if the grid goes down, which it does?
Shading devices, we had that screen the front and the back.
Okay.
And the courtyard spaces themselves, they are at least partially shaded by the buildings next to them. Full shading capacity with that.
And with the depth of the walls, we're not getting direct heat gain into the spaces. It is going to be hitting the sill. Thank you. So it's not going directly into the space, it not producing glare into the space, but it is still allowing light in.
For the common spaces, you mean? I mean, I meant for the actual living space, for the house itself. There doesn't seem to be much shading.
Correct.
Yeah.
It's bouncing up. We can go back to our floor plan here. We do a lot of still going. Yes, so like Zealand was stating, the southern buildings on each courtyard will be both shading the facade of the northern building up to about halfway on the facade. And then the actual sills will be bouncing, but it's a thick enough wall section that the angle of the sun will bounce off and enter the room in an undirect. It's more of a diffuse.
Okay. So one other thing, just to expand on that, and we were talking about passive systems, and in a climate that's so dramatically, changes throughout the year, it's kind of, there's few systems and tactics, to use, and we attempted to use the stack effect, right? We can get, approximately 16 or 600 hours out of the year out of that, which isn't a ton, but we did spec certain, some of our windows are operable to allow for ventilation. So yeah, that can help with that as well.
And with the humidity of, like you were saying, of Indiana, it is not a possibility for us to be using cooling towers or options like that, just because of the humidity that is.
When planning for our climate zone, we did also take into effect not only zone 5, which is us, but zone 6 due to climate change and the increasing zone changes. I think it was found that maybe a quarter of all Indiana counties are in the wrong zone now. So just trying to prepare for that.
Thank you. So I'll make a comment and then ask a question. I love your design. I love the kind of continuity of the shapes that you achieved and the difference in the heights as well, and how that kind of tells a story. I also cautioned the UCLA team, when you put up kind of a barrier like that, it does kind of cut you off, or it cuts the residents off. And it's not that I would want to see it removed, but I would love to see like more voids or more exploration of what that space could do. So you can respond to that if you want, but I was going to ask about your interiors too, because you had such beautiful interior renderings. Is one of you focused more on interiors, or are you all architects? Or
so we're all architects, but I really enjoy pre-visualization and rendering, so that's my forte.
And in terms of the rain screen, we had a insanely complicated grasshopper file that refused to be documented in any form of line work or anything that didn't crash the computer. So it's not represented great here, but it did have variable opening depending on proximity to windows and doors.
Okay, great.
That is something we were thinking about.
Yeah.
But it was a little bit fussy.
Yes, I get that.
Yeah, to respond to that too, it's like we were talking about, if we had more time to do this, we would ideally do like a study to see, what opacity is the ideal opacity to really, give the effect.
Yeah.
We want to get, sort of that mystery of what's behind, feeling sort of welcome and not like cut off.
Yeah.
And one last final comment on that. Throughout all of our presentations up until this point, when we've been presenting with our back at school, we have had Englewood CDC board members and community members on the calls to actually give their feedback. And something that we got feedback-wise was that our scheme followed a density that fit into the surrounding community, and it was something that they would be looking possibly for. So just in response to that.
Yeah.
We'll have some more time. Are there any other questions?
I was going to ask actually about your affordability study. Can you go back to those numbers? Sure. Did you really have like 23K median family income per person? That's staggeringly low.
Yes.
Right?
Which
it's like
Indiana.
Yeah, even for Indiana, it's staggeringly low. Yeah.
To Indianapolis as well, we are less than half, or Englewood is less than half of their median income, which is staggering. Very scary.
Yeah.
If you look at context, for instance, like we were saying, it is most of the community is either run down or abandoned homes. So Englewood community actually, the CDC, Englewood CDC is actually going through this initiative to provide low-income housing to the affordable areas. And right now there are 20 projects that are currently slated and in actually the process of being built across Englewood to help support these communities. So it's a really, really rough problem currently.
So would the state give you some money to help with that, kind of revitalize the neighborhoods?
I think we were
Potentially.
looking into some grants. And there are certain products that we are speccing, like those UV air scrubbers, that actually the government will give a grant for installation and procurement. So
great.
We're looking to subsidize in that way.
So where are people traveling to in 24 minutes? What's the major employer for this proposed project?
I think that's just statistics speaks more towards the commute to EV, like the
Downtown, okay. So you're hoping to attract people who work in downtown?
So always a family-oriented development. So trying to get new families, especially moving into this area.
Right.
And with the pathway of rent to own, that will allow for the occupants to build a family and potentially own the house at that point.
We took into account from beginning to end this drawing in of young families and then aging in place. They never really have to find another home. This is their home, not their house.
That was a great job. Thank you, Basti. With that, we come to an end for today's presentations. I thank you all for joining, and all the students are welcome to join us at the RSF for a networking session, and there will be food.